Who's a good boy? Who's a good boy? Floppy ears? Yeah. Hi. Hi, Bubbo. Hey. Who's a good boy? Hi. Hi. You're so soft. Hi. I got you, S'mores. What have I missed? What have I missed? Oh my god. He's not a bear, okay? That's the first thing we gotta talk about is he's not a bear. It doesn't matter if it's legal to keep bears in a home because S'mores is not a bear. I'm not being mauled, it's not a bear. It's not a bear. Thank you, Dave VVE FTW for 63 months. Hell yeah, cheers. Is this the annual Gamozo stream? Well, it's a new year. Get up at that dog. Get up at that dog. Is that carpet or his last hunt? Hi, Chaos Mix. Thank you so much for the 1 year. Or the sub. I read the tier 1 as 1 year, but thank you for the 1 year anyways. Happy New Year. Audio's a little scuffed. Is it scuffed because it's plugged in? Is it now not scuffed? I think it's scuffed when it's plugged into charge. Is it because you're hearing fan noise? Is that what you're hearing? You're hearing fan noise? Because it's close to a fan. Like, how scuffed we talking? I probably should have checked the mic. I can switch to the camera internal mic. Here we go. Ready? Here we go. Right ear kind of weird. Right ear kind of weird. Properties. Audio properties. Mono. Okay. Is that better? This is only left. Here's right. Here's only left. Is that an improvement? That's better? Really? Okay. In OBS, I set it to just on the media source. I set the balance. I set it to mono, and I set the balance all the way to the left. My interpretation is that is making it take in only the left input and then duplicating it to mono? Question mark? I don't know. It's kind of a janky setup because this is my like floofy mic, not It worked at least. It did work. We're fine. We're right. We're fine. We're fine. We're fine. We're fine. It's fine. Okay. Thank God. Good boy, Smart. We figured it out. We figured out how to do it. Hi, Boo-Boo. Who's a good boy? Who's a good boy? Yeah. Give me a kiss. Can you give me a kiss? Good boy. You're such a good boy, S'mores. Hi. Do you want to say hi to the camera? You see the camera? Yeah, say hi. Yeah, he sees himself. He sees himself on the screen. You are so smart. Yeah, that's an enemy. That's an enemy. Okay, don't whip the camera off the table with your tail. Nice dreidel plushie. Yeah, I had to get that because one of my friends is Jewish. He sees another bear. He's not a bear! If he were a bear, then why would he look like this? And do bears like carrots? I bet bears don't like carrots. Yeah! Who's a good boy? Who's a good boy? Who's a good boy? Who's a good boy? Wah! Ah! Hi, Bubbo. Look at you. You're so easy to scratch. Are you? Oh, you giving me a carrot? No, you're not. Yeah. Oh, you flipped it. You flipped the carrot. You flipped the carrot, Morris. Good boy. Good boy. Yeah. I got you carrot. Hi, Schwartz. Are you having a good day? He was just outside for a long time, so he's kind of tired right now. This is probably his last energy before it's nap time. Yeah? Is that what you think? Hi. 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 Hi, Bubbo. Hi, Bubbo. Who's a good boy? Who's a good boy? Are you a good boy? Oh! I almost took it. I almost took it, S'mores. I almost took it. Do you like the carrot, S'mores? Yeah. Which one are you gonna pick, the carrot or me, S'mores? The carrot. Good carrot. Good carrot, S'mores. No licking my belly, S'mores, you goofball. Who's your good boy? Who's your good boy? Are you tired, S'mores? Was that a lot of work? Hi. Yeah, that's me. That's me. Are you saying you want pets? Is that what you want? You want pets? I'll give you pets. I'll give you pets, Bubble. Who's a good boy? Who's a good boy? You're so fluffy. Where'd you get all this fluff from? The fluff store? You want more pets, or do you want the carrot? Or both? You are so tired. Yo, hi. Hi, Bubble. Hi. Now you have me and the carrot. You're a good boy. Is this fun? Are you entertaining the stream? Because we gotta go and do some work, okay? Are you gonna be able to take a nap? Are you tired out enough to take a nap while we go into the garage and work on the lathe? Yeah. Yeah. Good boy. Good boy, S'mores. Yeah. Yeah. You're so soft. Hi. Who's a good boy? Are you a good boy, S'mores? Are you a good boy? Are you a good boy? Yeah. Yellow goofball. Okay, what have I missed? What have I missed? In general, they don't like most vegetables. They really only eat carrots. I think you're full of shit. That is tired, yeah. Dogs have 42 teeth? I didn't know that. Thank you, Desu, for the 49 months. You're so smart, it's an enemy. I try and teach him. I'm trying to teach him to be vicious so he can defend me and protect me. What kind of bear is that? It's just a regular black bear. It's a Bernese Mountain Dog. It's a Bernese Mountain Dog. Okay, Mr. S'mores. Why do I have the exposure, or what's my, where are my settings at? Here we go. Let's go to 1/60th instead of 1/250th. S'mores, did you lick the lens? Did you lick the lens, S'mores? Did he lick the lens? You little goofball. Are you being a little goofball? Yeah. S'mores, look at this big piece of fuzz. You made that. You made that fuzz. That's all you. You did that. Well, don't eat it, S'mores. S'mores, you're just gonna poop that out later. God damn it. You little goof. Does fuzz taste good, S'mores? Do you like the taste of fuzz? Is that your favorite? Nice, S'mores. Hi, Above Seagull. Thank you for the 59 months. I'm trying to train him to be vicious, but he's not vicious. Chat is being mauled. Yeah, chat got real mauled there, didn't you? Didn't you? S'mores, did you attack chat? I finished a thing of peanut butter, so I gave him the peanut butter so he could lick out the rest of the jar, and he did a very good job, didn't you, S'mores? Didn't you? Yeah. You are tired. You want to show them some tricks? Do you want to sit? Do you want to sit? Sit. S'mores, sit. Come on, you're very obedient. You're a very good boy. Shake. You want to shake? Oh, good boy. Good boy. You probably did that off camera. But they'll believe us, S'mores, okay? They will believe us. Twitch chat loves us, S'mores. Good boy. He just likes rubs at all times. He's so needy. Aren't you, S'mores? Do you like your back rubs? Now, we're gonna have to assemble the camera, S'mores, because we started streaming when the camera's in like 8 pieces. So we're hopefully going to be able to hook it all up to the stand, because we need to do that, don't we, S'mores? What do you think? Yeah? Are you going to behave? Are you going to behave when I get the stand out and I start moving things around, or are you going to go crazy? You're going to be a good boy? Okay. He said he's going to be a good boy. Let me go get the camera stand. Come on, S'mores, let's go get the tripod. Yeah. Yeah. Here we go. Here's the tripod. Meow. Come on back. Come on back. Mr. S'mores, he's a good boy. Mr. S'mores, he's such a good little boy. Boo, 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 doo, boo. Mr. S'mores, how do we open the stand? Just a little bit of force, Mr. S'mores. Boo, 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 boo. S'mores is amazing, but you want the Monarch. Well, I'm working on it. I gotta assemble everything. Because I streamed unprepared. Oh no, this has got a thing in there. I'm gonna need a screwdriver. S'mores, keep them entertained, okay? S'mores, entertain them. S'mores, you're not entertaining the stream. Yeah, I got a screwdriver. Go get your ball. Good boy. Good boy. Mr. S'mores, he's so soft. He's the fluffiest guy aloft. Mr. S'mores, he's licking the tripod, helping us out a lot. Mr. S'mores, he's the best. He's soft and fluffy like the rest. Boo doo doo doo, Mr. S'mores. How was this all put together? Does that go on this? That goes on that? Where's the thing that lets me mount the thing? Oh, let me know if plugging this in ruins the audio quality, but the mic needs a charge. So I'm plugging it in. Hopefully that's not noise when it's like charging before. Okay, so there's this thing. That grabs onto a thing. But which thing does it grab onto? Not that one. And this is for here, which needs to go into here. Mr. S'mores, he's drinking some water. He's drinking water, Mr. Otter. Mr. S'mores, he's the bestest boy. Boo-doo-boo. Okay. One second, I'll read chat in a minute. This is always a pain to get all this in here. There's like a million pieces. And the camera's not in its jail right now. Which is where the camera needs to go. I need to put the camera in jail. Hopefully I don't have to disconnect anything, because that would probably break everything in the stream. Okay, so the camera goes into here. Uh-huh. That's like an adapter, okay. Was I using that adapter? That goes in there. Does it go in? I might have to turn the camera off for a second. Let's see what happens. Is that working? Did we do it? Did we do it? I think it works. And then, oh, I put the camera on backwards. Classic. Okay. Okay. You guys are just jealous of American houses. Okay. At least in America, you're allowed to own a house. Got him. Got him. Whew. Okay. Okay. That feels pretty good. What about, let's make sure everything is zeroed here. Okay, now we get to shoot some s'mores footage. S'mores, tell us about your day, okay? A wild s'mores is known for sitting and admiring all of the scenes that are nearby. Currently, he's looking at himself on the other monitor. This is a primal instinct of the s'mores to make sure that there are no other enemy s'mores nearby. His tail wags only when excited. S'mores is coming in. Hey, no licking the lens, S'mores. That's gonna be hard to clean, okay? S'mores! S'mores! S'mores. Okay. Sit. S'mores, sit. Sit down. Sit down. Good boy! Now this is a good boy in his natural habitat. Look at that. A very good boy. Uh-oh, this antenna is a little disconnected. Let's see if I can get that fixed. Oh, okay. Okay, don't know what happened to that antenna. Chat, how do you like the footage? Happy New Year. I just bought a house. Hell yeah. Since when did you have a dog? I got S'mores in June. So about half a year now. Actually more than half a year. That's wild. I feel like I just got him. And he's still a little baby puppy. And he's tiny. And he's not a bear. Even though everyone in chat says he's a bear, he's not a bear. Isn't that right, S'mores? Yeah. Yeah. Good boy. Okay. Are you ready to go work in the shop, S'mores? Oh, I should pull out this SSD. Hopefully this doesn't break anything. There we go. No need for the SSD where we're going. Okay, stream is coming in. Microphone allegedly works. Do you brush him? Yeah, I brush him every couple days, roughly-ish. Such a cutie, he is the best. He's so soft, he's so fluffy, he's very cuddly. He likes just hanging out and snuggling. Isn't that right? Isn't that right? Are you biting me? Are you biting me, S'mores? Yeah, who's a good boy? Who's a good boy? Here's your carrot. Yeah, give it a good squeak. Give it a good squeak, S'mores. Give it a good squeak. S'mores, give me a kiss. Give me a kiss, S'mores. No, Are you cooked? Are you cooked? Are you cooked, S'mores? Yeah. Yeah, good boy. You're such a good boy. You're such a good boy. You're such a good boy. There you go. Have your carrot. Okay, we're gonna go into the garage, S'mores. Okay, we're gonna go get some water, and then we're gonna go into the garage. Okay? You gonna be a good boy? Okay. He said he's gonna be a good boy. Here we have a Gamozo in his natural habitat. Yeah, he looks at me like this, and I can't resist. Okay, I'm gonna get some water, and we'll get ready. Mr. S'mores. Mr. S'mores, he's coming to see me. Mr. S'mores, you're not entertaining stream. Mr. S'mores, you're all waggy and happy. Mr. S'mores, good to see. Yeah. Yeah. Get some water. This is for me. You already have a full bowl. I just filled it up. Give me a little move. Mr. S'mores, waiting at the wall. You're waiting at the wall for me to come back. Mr. S'mores, you're a good boy. You ready to go garaging? Okay, S'mores, we're going into the garage. Yeah! Okay, I'm gonna unplug the power to everything, and hopefully everything still works, because that's how this whole setup is designed. Otherwise, he has to pay rent. S'mores. S'mores, would you ever pay rent? No. Okay, unplugging power. Here we go. Disengage. Okay, we're alive. I don't know how good these batteries are still. I imagine I can get some runtime off of this. Battery still reads 5 bars, so that's a good sign. Okay, we gotta move this whole setup, S'mores, okay? You ready? We hate doing this. This is not fun. I'm gonna bring this out first. Yeah? Mr. S'mores, clearing a path. Gotta make room. Go outside. Mr. S'mores, clearing a path. Okay, here we go, Mr. S'mores. Mr. S'mores, he's gotta be good boy. You ready, S'mores? Here we go. This is so heavy, Chad. Okay. It's way better when I don't have to fight the door. Okay. Leave. S'mores. S'mores. S'moresies. You're not supposed to be here. You're not supposed to be down here. Let me log into Twitch chat, S'mores. Yeah, Twitch chat is where all the D-gens are. So we're gonna go into Twitch chat so we can see what all the people are saying. Now, Twitch chatters, S'mores, Twitch chatters have no life. They're kind of losers. But that's okay. It's okay to be a loser, right, S'mores? Yeah. Oh, do I remember my password? Oh, God. Okay. Here we go. Getting this. Okay. Now, I have Twitch chat. Is S'mores a shop dog? I guess right now he is. I don't really mind when he comes out here when it's clean. It's fairly clean right now, so I'm not too worried about it. But if there's a lot of metal on the ground, I don't like having him out here. But yeah, okay, I got Twitch chat. Press 1 if you're a Twitch chat. Okay, S'mores, we gotta go get water. Yeah, you wanna go up? Yeah. You big lard ass. Okay, good boy. You did a good job. He's the bestest little boy. They going back out, S'mores? You sniffing? What you smell? All right. S'mores has been hidden. I have water. Chat, should I hop in a Discord call so chat can chat to me when I can't see what's going on? Does that sound fun? Let's see. Join voice? How does this work? Okay. I'm in voice chat. How do I set up music in Discord? Should we just make it so we have a music bot in Discord for people who want to listen to music? Because I have my headphones in. And I feel like having my headphones in is a nice experience in the garage. Okay, what, I think we actually kind of want to stay down here. So that's where you are, Twitch chat. You can wave to yourselves. Say, hello, Twitch chat! Oh, I should plug in everything before all our batteries die. What is our battery at? Our battery is at 4 bars. Okay. Where is are there an outlet? I think there's one up here. Oh, there is, but it's so far. Do I want to run an extension cord around? Not really. I have one out, but it's the super long one. I kind of don't want to deal with the super long extension cord. Fuck it. Okay. Unraveling extension cord. I put it in backwards. Scoop boop boo doo bop. Skibbity toilet. Okay. Now we have an extension cord. And we'll plug it in. And now we have power. And then we have to plug in the other end. And since we're American, we might electrocute ourselves because their adapters aren't made to make it safe for us Americans. I'm just kidding. Okay, and then we plug in into the BP charger. And now we should be charging on the camera. Okay? And now we can go anywhere for as long as we want. Okay. It's also 120 volts, so you'll be fine, Sag. No one joined the Discord call. Wow. Bunch of shy people over here. How do I set up music in Discord? What's the best music bot for Discord these days? Discord best music bot. Can't wait for a top 10 AI generated thing. Skibbity toilet man. Ba-doop-a-da. The one you write yourself. We're not writing a Discord bot, okay? How do I rhythm or groovy? Rhythm Discord bot. But Mom! Yeah, we'll threaten to write one when things aren't going well. Do we trust discord.bots.gg? Okay. Invite this bot. Add to server. Fuzzing with Gamozo. And I have to multi-factor auth? Oh god. Yeah, I am a human. Okay. Added. Okay. Now how do I use it? Was I not supposed to use discord.bots.gg? Was that okay? Or did I just backdoor my, my server? No idea. Okay. How do I use this? Wait, they shut down? I'm starting to question if I'm getting pwned here. Skibidi-ba. Bots. Okay, it is a verified app. And then I can do like play. Okay. How does that work? I go into here. Oops. Didn't mean to do that. Open chat. /play. Okay, I gotta join the chat. Okay, this is very difficult. Join. Okay, and then play, and then do I just pick a YouTube video? Oh my god, I'm not logged into YouTube. Hey, stop staring at my ass! You weirdos. Okay, how does this work? I need music. Give me a pop hits of 2024, okay? So what's this? I joined the rhythm session? Okay, get started. There's listening rooms. The fuck is this? What is this? This is advanced. Okay. Can I play? This isn't working. Okay. I'm in an activity. Is that good? Do I want to play the edgelord radio? And then, do I have to join this room? If I go to chat, and then I started a rhythm session, and then how do I join the rhythm session? Because I'm allegedly in session start. Only I can see this. Okay. So I'm starting a session. Okay. And now add a song to get started. Okay. How do I pick a song? Add music. I'm gonna add anime music. Start the anime radio. Okay, I did it. Now can you people join this? Is that how that works? How do I share it? How do I share the rhythm session? Oh, there's a join activity button. Okay, so you guys can join it. Alright, we did it. Now we'll listen to weed music. I don't know if we get to pick anything, but we got Wheat music. Does this work? Does this work? Because I'm in an activity. Is that good? Dude, we're crushing it right now. We're professional streamers. Alright. Today we're going to be working on improving the precision of this beautiful Monarch 10EE over here that I currently have set up on the ground. And that is intentional. Oh. So this is the lathe. I currently have it off the actual bed of the machine, or the base of the machine. I think base is the correct term. And should we change our f-stop? Let's go to, let's see. Can we do like an F3.2 is ISO 320. I think we could go to like F9. F9 and we're at ISO 3200. That way a little bit more is in focus here. Does that work? But yeah, I'm listening to music. It's very quiet. Is that just because the music is quiet? Oh. Yeah, it doesn't get very loud. What kind of music do we want? Can I not pick? I have to pick from a playlist? Can I search for songs? This looks like it's super neutered in terms of who can, the music that's here. So yeah, we're gonna have to stick with the, do we want driving music? Do we want, Let's see what their emo playlist is like. Okay. Okay, that's a real song. I wonder if we'll get ads. Okay, chat. So this is the lathe. I'm gonna turn the monitor around so I can see what I'm actually doing. Okay, how's camera quality? Are we good? Are we good, chat? I think we're good. I think we're crushing it right now. Alright, so, what we have to do is we have to level the lathe. So right now, this is very level, but it's not level enough. So I'm gonna clean off kind of the markings I had. Actually, I want to keep these markings here. So I want to clean only a little bit of these off, but the other bed I can clean the whole thing. So we're going to start with cleaning everything off real good. Okay. So what we need to do is we need to measure the lathe here, and we need to see what shape it's in. Okay, I want to leave those markings because those markings are the spacing which I do measurements. Okay, that looks good. Feels good. So, we have to get the level out and calibrate it. Alright? So, let's go over to the surface plate, which is right over here, and I think I'm going to have to extend the camera a little bit up. I keep hitting that. Okay. Okay, how level are we right now? Not very, but it's probably okay-ish. We'll level it. We'll level it. If I remember correctly, this isn't that bad, the level. Okay. This way. Yeah, that level's pretty easy. Okay. So here we have the surface plate. The surface plate right now is very dirty. I can feel just a lot of like dust particles on there, which is bad. We don't want dust particles. So let's just clear those off. So we might use a little bit of a cleaner on this, depending on how dirty it feels. But I think that's cleaning up pretty good. Okay. I just want to make sure it's nice and clean. And we're going to calibrate our level on this. So we know that this surface plate has a big hole in the middle, right? And we're not very happy about that hole, but there's, we're going to have to relap that surface plate if we want to improve it. So, set this elsewhere. Okay. So, we get to bring the level out. This is the new fun, is the level. What's Twitch chat saying? Let me pop up Twitch chat. Maybe I can read it from across the room if I like pop it out and make it big enough. Unfortunately, if you zoom in, it fucks up the a bunch of the margins for the other things that show up on the chat screen, like your chat message. Okay, so we're gonna open up the level. We don't really need anything except for the level out of here, so let's just grab that. Come on. There it is. Okay. Alright. The level has been brought out. So, what we need to do is we need to calibrate this to figure out where absolute zero is. Because right now the lathe, according to my software, the lathe is slightly out of level compared to the nearest plane that I want to actually flatten it to. So I'm just going to make sure that all these feet are clean and there's nothing on the plate. Looks good. We'll boot up that level. Okay. What does micron tolerance means? It means that I want to I want to basically have the lathe bed, the like flat parts of the lathe bed right now is what we're working on. I want to have those within about 1 micron. So like if you think about it as like waves or holes or pits, I don't want any of those to be greater than 1 micron. So the level actually looks like it's very close to 0 unless the surface plate is moved. Do I want to raise you guys up? Not really. I'm going to just 0 it quick and then we'll move over to the lathe because I don't want to keep adjusting the height of the tripod because we're not going to be doing really any work up here on the surface plate. So the way you calibrate or the way you find absolute 0 on a level is you rotate it 180 degrees. So what I should have done is make sure that's lined up with these lines. And it is. Probably going to have to redo this because that probably wasn't stable. So let's go in and just cancel that. So what I'm going to do is this is going to basically find the current level point, the current reading, and the view is that, assuming that this plate is flat and isn't adjusting its level, it should read the exact same value in this orientation, and then when we flip it around 180 degrees, it should read the same value, but inverted. And so that's what we're going to do. We're going to flip it around. Going to make sure that it's in the same line.
And this is how you calibrate a level. Now with a normal analog level, it's a lot harder to do this because you have to get in there with like a set screw and adjust the actual glass on the vial itself until you get the same reading on both sides. But there we go. And yeah, we're reading plus, let's see, letting that settle a bit. We're high 5 micron over here, well 5 micron per meter here, and then we're high 2 micron per meter here. And if we switch it around, we should hopefully see roughly the same thing. Now keep in mind, we're actually going to measure variance of the surface plate itself here. Now we're down 5 micron per meter here, and we're down 3 micron per meter here. So it's reading nice there. Okay, so let me get this level down onto the lathe bed so that you guys can see it better. And I might have to figure out a good place for the camera to set up. So I'm hoping that this lathe hasn't been moving a lot. That surface plate has actually been really stable in terms of not moving around. Okay. Let's see. We're going to want to come in pretty close, I think, here. And we'll see if we can get rid of that glare. I want to go this way. I don't know if that level is readable at all, is it? I could turn up the brightness on it. I don't know how much that affects battery life. I don't think too much. Display. Oh, that's the different display types. I think it's just in like settings. Options, display settings, brightness. Okay. There's a different brightness for when it's on battery, which it is right now. Display settings, brightness, battery. Let's just turn it to 100%. Okay. Is that readable? Yeah, that's roughly readable. Okay, so this is reading high here. I wonder if I have a piece of dust under there. Because I don't think this has been that far off. So there's this one area that I scraped a hole into intentionally. And that should read roughly 0, 0 in the center. So let's go to there. And then let's make sure that we're running straight. That looks about right. Okay, yeah, so that's reading 7 micron per meter high here and 31 micron per meter low here. Currently the feet of this level, so here's the feet. So on the bottom of the level is this base, so you have 3 feet here that make contact. So 1, 2, and 3. This is in the y-axis, and this is in the x-axis. These are adjustable in their positions. Right now, all 3 of them are set at 190 millimeters apart from each other. So if you take these readings in micron per meter, for example, like once this settles in, so this reads, yeah, the x-axis here is positive 8 micron per meter, and that means that on the 190 millimeter base, you want to multiply this by 1,000 divided by 190. So, which actually means that this point is probably, is that right? Yeah, like 70 micron high, maybe? Is that true? No. The other way. The other way. Multiplied by 190 over 1,000. So it's actually, yeah, it's more like it's 2 micron high here, and this side is maybe 4 micron high, or 4 micron low. So effectively, what I'm trying to do is I'm trying to get everything here so that when I get all these readings, I get the exact same readings across the entire lathe, which means that there would be no twist, no bend, none of those other things. So I wish I could like flip the display around. I don't know if I can. I don't think so. Gravity, display. I can change the color. Chat, what looks best? blue, yellow, white, black on white, white on black, white on blue, black on yellow. Which one's most readable? I imagine probably the white on black. Maybe the black on white. White on black. White on black? Okay. There you go. I didn't even know I could do that. That probably saves battery a little bit. I think this is like an OLED where it actually has those pixels off. I'm not 100% sure. So yeah, right now it's reading, and I can turn my focus thing off. Okay, that's actually quite readable. Now, let me see if I can get the camera on the other side. So you can see this lathe bed has two flats. So it has one flat here, and it has one flat here. Now, I need to use the level in this specific orientation because I have to be able to measure up in this area of the lathe, which requires it being in this rotation. So I can't just rotate it for you. I mean, for literal demonstration, or when we're not actually measuring in that territory, we can just put it over here. But I pretty much do all my measurements in the other orientation. So we can see that this is kind of settling in, and I can go and try and hit that same spot that I was on before, which was, where's the scrape patch? Here. So I'm going to go roughly over here. And it was reading like 8 micron per meter high here, so it should now read like 8 micron per meter low on X if I get it in the same position, which is very difficult here. I think like this is roughly where it was. Yeah, and it's reading 12 micron per meter, which is probably just noise in me having the level sit on a different spot. Let me change your position here. Okay, so that is effectively how I'm taking the measurements on the lathe here and figuring out the geometry and whether or not things are warped or distorted. How did you measure the position from end to end in your plot? Okay, so Askell is asking about the plot that I made, and since I'm doing this like camera setup, I don't have a fantastic way of showing you that. Let me see if this is really cringe, chat. Okay, so please hold in your cringes. We might do a little bit of this. No? Actually, I can output HDMI into this. I think I can do that. So I'm going, let's get a little bit more cozied up in here. So I'm going to try and make room over here so I can have you facing this way, so that when I'm doing my level readings, they make sense. I might, actually, I think I can just put you here. But I think I might be able to swap the HDMI output from the computer into this camera. And then maybe we can show you the software. Okay. So let's sneak this camera in here. Hopefully we don't bump the lathe off and crash it on the floor. No, it should be pretty stable. Okay. Okay, and then I have to adjust the panning arm thingy, whatever this would be called, to be lower. There we go. So then when we're doing readings down there, this should be semi-readable. I also can pull it in just a little bit more. Now I'm kind of standing over the lathe. Okay, lock that in, and I'll flip this around. We'll go to that same spot. Now it's way easier for me to hit this because this is what orientation I'm used to using. And this should be that 8 micron per meter low here again. Okay. See, I could maybe raise the camera up and then have more of like a top-down view. Thoughts? Keep going in the workshop? Yeah, okay. So chat, instead of what I said I was gonna do, we're not gonna give you a live output. Instead, we'll just like upload an image somewhere. How does that sound? So let's go, and I think I posted it in Discord recently. Metrology. Yes, that is the most recent image. So let me open that in browser. Okay. Are you able to use this link, chat? I don't know if you'll, okay, yep, nice. I don't know if you have to be in the community or not. So effectively, this graph, what I have done is I've drawn these dots on here. I don't know if those dots will be visible, but I've drawn these small dots every 20 millimeters. And what I've done is I've set this up so the back foot, this back side of the back foot is on the dot, and then I kind of feel out over here to make sure that I have the same gaps on each side to make sure that it's roughly in the same orientation. And what I did is I just went down the lathe and I gathered all of the data points doing this. So it's a pretty long process, but you can see that like the first point here is positive 145 micron per meter and positive 150 micron per meter. And what that is saying is that relative to this point here, this is high, and this is also high. So we know that, effectively, this point to this point, this point must be higher than this point. So what I've done is I've written some software that takes all of those measurements, and it tries to minimize the distance between the feet contact points in terms of the z-axis, like the height of those points, while preserving the slope requirements. So effectively, for all of these measurements that you see on the image that I've posted in chat, you can see all of those contact feet, and you can see that on the long side of the lathe bed, that there are like, the contact feet are way more overlapping. And that's because there's two contact feet over here. So that when I get towards the center area, I'm actually seeing these in multiple points. So I'm seeing them on the back foot, but I'm also seeing it, that same point, roughly, on the front foot. And what the software is doing is it is using all of the level readings that it got, and it is trying to basically make sure that any points that the feet are overlapping with other measurements of the feet, I'm assuming that those feet, those positions, should be extremely close to each other, because that makes sense. It's literally the same spot that the level was sitting. So that has allowed me to build this graph that is representing the current shape of the lathe. So really what we know is that there's a big hole right here, and this is kind of the lowest part of the entire lathe, is in this area up here. And we also know that there's kind of a low spot on the back over here that's off camera right now. So we know that there's also a low spot towards the end of that bed. But you'll also see that there's a hole right here in the graph. You can see there's just a very localized dent. And that is an area that I have explicitly scraped to try to see what happens when I do like a really local scraping to get that geometry in that spot. And you can see that did work. I was able to get it quite low there. And what I want to experiment with is trying to get random things on the lathe, random positions on the lathe, basically at absolute zero. So today I want to be setting up effectively the origin of this lathe, which is what we'll be scraping everything to. So my plan is to level the lathe using the leveling feet that are under it to adjust it such that 0, 0, reading out on the level, is what we actually want to scrape down to. So like right now, for example, if it was in that position, we would know that, once this settles, we would know that this is high, so we want to scrape this down. We know that this is low, so we want to scrape this point down. Now keep in mind, since we're measuring two angles, adjusting one of them will affect the other, right? Because if we scrape this down, this whole assembly will effectively rotate towards that location. We're assuming that this is infinitely rigid. Obviously, we kind of have to do that. Okay. So then you can lay a plane in there and minimize the difference to see how deep you need to go at that spot. Yeah, effectively. So, right now, I have a plot that I can share, that I posted somewhere. Let me see. So I do a lot of this work inside. Here we go. So here's another link that I'll share. Now this is a graph. This is a graph that is showing the X and Y axis readings of the lathe as I scrape that one spot. So once again, there's this small little patch here that has a slightly different color. I don't know if that will show up on camera, but I basically scraped a tiny spot right here, and the goal was to get it very close to 0, 0. And then I scraped this area over here to adjust for it, and you can see that progress. So every data point on the graph that I've linked, the most recent image, that is a data point of the X and the Y readings. And I started off by working on X, because the X reading was initially 100 micron per meter, I think, roughly. And then I scraped down and down and down and down and down until that got to 0. And then once that hit 0, then I started working on the Y-axis until I got that to 0. And at the end, I got both of them quite close to 0. And you can see that when I have the level sitting here, which is, this is probably roughly where I was doing the work. I think it was a little bit over. It's really important to note exactly where you're working. But yeah, it's reading 25 high here and 15 low here. So whenever I say a reading, I'm just going to be talking in micron per meter. So we're talking about slope, not the absolute value. In reality, if you want to take these numbers and divide them by roughly 5, that's actually what the difference is. So right now, this is maybe 5 micrometers high, and this is maybe 4 micrometers low. And what I need to do first is to minimize the amount of labor that I have to do to scrape these things down. Because if you see that graph where I scraped in just that one spot, it took roughly an hour to do that, which is not terrible, but I have to do that to the whole lathe bed. I would say, assuming that we have a really good methodology and really good execution, we probably could do everything here in 20 hours of work. But in reality, we'll probably have some mistakes. We'll probably overcorrect some areas. We'll probably end up making a new hole. And thus, I think like 30 to 40 hours of work is probably more realistic. That includes kind of the measurement time. So it's important, due to the amount of work that has to be done to actually get this, like the amount of time it takes to do the scraping, what's important to me is that we start with the easiest to scrape plane. So what we want to do is we want to make sure that we effectively want to find the nearest plane to the existing lathe bed. So assuming that we perfectly scraped only the high spots, how much scraping do we have to do, and what plane do we end up with? Basically, what is the nearest plane to this only using material removal? Obviously, we can't add material back in, so we can only remove material. So it's also important that we don't overshoot, because if we overshoot, we end up having to redo work. In fact, if we make a hole somewhere, we can't fill in that hole. We have to then go and make everything else the same depth as that hole. So it's really important that we basically aren't being stupid and wasting cycles here. So what I have decided that we're going to do is we are going to adjust the lathe, the level of the lathe, to that plane. So in software, I'm going to determine the plane, like the nearest plane that minimizes the amount of work to do. And then we're going to set the lathe level to that, such that 0, 0 on the level, absolute 0, 0, with respect to gravity, because right now this level is in absolute mode. It's actually very easy for me to level this lathe very precisely. So we'll set the actual level of the lathe to that nearest plane, and then the goal will be to transfer the lowest point, which is like right now roughly here. I want to transfer that to a hole over here, and then transfer that hole over here to a hole over here, and now I should have 3 points that are at 0, 0, right? And then I can move this another 180, and then I can try and transfer the low spot from this hole to the next hole, right? And I can do that over and over. And the goal here, and the strategy I have, is that I effectively want to transfer these little holes throughout the entire bed that are maybe like 2 inches wide or something, and effectively build this like sine wave throughout the bed so that there's just these low dips all over the place. Then what I can do is I can use a precision straight edge, set it on top, and I can use that straight edge to blue all the high spots. Then I can attack the high spots, and I can just go as ham as I want, and I don't really have to care what I'm doing there. I just scrape all of those spots until I, for the first time, see blue showing up in one of those troughs that we intentionally scraped in. And once I see blue showing up in one of those troughs, I have to then start making sure that I'm actually doing the right, getting accurate measurements on the level, or on the straight edge. So effectively the goal is to do a small amount of labor to build a bunch of reference holes, and then I can use kind of the more traditional bluing, which is prone to a lot of errors, but I can just do that however I want until I start seeing those holes get filled in, or once we start scraping down into those holes, and then I have to worry about, like, am I focusing too much and am I, like, leaving a tilt on it? For example, if I were to make equal size holes everywhere, and then I only start seeing holes up here starting to get blue, I know that I have been scraping more on this side, and I'm leaving kind of a slope. But until I see that blue show up, I know that there's no material being removed that is not supposed to be removed. So I don't really care how accurate my readings are, as long as those holes are roughly spaced out. So that is my theory. I've never really read anyone who scrapes like that, mainly because you kind of need a level like this to do that style of scraping. But my view is that should work. But I don't know. It might not work. That strategy might be a bad strategy. So I die trying to get everything perfectly level. Yeah, so I think what we're going to have to do, chat, is I think we're going to have to do a sweep of the lathe and get accurate measurements today, because I don't necessarily know what the current measurements... Basically, this lathe has probably drifted a little bit with temperature changes. The scraping work that I did has probably finally propagated some stresses through, which has just warped things just a little bit. And also, who knows, just the concrete could have settled. There's a lot of things that can affect this lathe, but I did build these really, really cool leveling stands that I made myself. They're one of my first kind of large tool projects. So I'm going to take you off the stand here. to show you. So you can see that the level, or the lathe is currently sitting on 3 feet. Right? And I built these feet, and they have a small base here. That base only has a small ring of contact around them. And effectively, it's got a really fine thread. That's an M20, so a 20 millimeter diameter metric thread with a 1.5 millimeter pitch, which is quite a fine thread pitch for a thread that size. And then I have like these little balls that I machined onto the top of the thread, so I can put various different kind of feet on here. So right now I want really small feet. It actually doesn't matter too much, but when I flip the lathe over, I'm going to need really small feet. So over here you can see that I have the ball just going raw into one of the thread points, because that just gives it a really nice rigid connection and kind of gives it some lateral stability. And the other foot has that pad on it. So effectively this entire bed is supported by these feet. And these feet, this is solid 3/16 stainless, like 2.5 inch diameter, except for the 20 millimeter hole for the thread in the middle. So this is extremely rigid. And the reason that I wanted this to be really rigid is that the more rigid this is, the less warping and buckling would happen over time. Because I don't want to go in for the night and then come out the next day and the lathe has, caused this to squish by 50 micron, and then that causes all my readings from the previous day to basically be invalid because the lathe has settled into a different position, if that makes sense. So those are the little feet that I built, and they're meant to keep the lathe high enough off the ground so that when I finish this top part, I have to go in and then I have to level the lathe with respect to the flats that I'm making now so that I can scrape the bottom, because the bottom actually makes contact with the base, so all of this needs to be scraped in. But this is not hardened. What we're scraping right now on the bed, this is all hardened, so this takes like 10 times more time to scrape the same amount off. This is just soft original casting, so we'll then scrape these points in so that they're parallel to the top of the lathe. The reason that these feet are so high is, first of all, so when I'm scraping, it's just a little higher. But second of all, once I have finished one side and I want to work on making it parallel, I will need to be able to fit a level underneath here so I can, effectively, assuming that this top part, these two things are perfectly flat, what I need to do is then flip the lathe over on the feet and then level the lathe until I get a reading of 0, 0 upside down on here, which effectively tells me that now the top also needs to read 0, 0. So then I'll scrape the other side in, and then I should have a nice parallel surface, if that makes sense. So that is the theory here. And it's a lot of work, but this level is going to make it a lot easier. I've probably already put 200 plus hours into this lathe bed, and I'd imagine that 90% of that work has been wasted because I've had inaccurate readings, things haven't measured right, I've scraped more than I needed to, or I ended up scraping the whole area instead of scraping just the high spots. So I'm trying to approach this kind of with logic and data, and seeing that I was able to get this one spot to converge was a fantastic sign. Why not use 4 feet instead of 3? So the reason that you use 3 feet for pretty much anything in the precision world, like my surface plate is 3 feet, is because if you use 4 feet, you can introduce twisting, right? If you have 1 foot is too high, you'll end up getting a twist in there. So 3 feet, you can theoretically never get a twist because it's supported by 3 points, which is the fewest number of points that can define a plane, and thus there's only one plane that it can rest in. So, unfortunately, having 3 feet is slightly less stable, in terms of it's easier to tip things over and stuff. And that's why you don't really see like 3 feet on chairs and stuff, because you need a very wide base. But for something like this, it's actually totally fine because we do have that really wide base here. So, okay. Okay, my Twitch chat crashed for some reason. Alright. Looks like my whole edge crashed. So what we're going to do is we're going to go in and I think we're just going to take a new reading of the lathe as it sits right now. And then we're going to use that. We're going to mark a very, very, very specific spot that is going to be the area that will be our reference position. But first we have to start by kind of doing a sweep. So I could maybe do like an abbreviated one. Because how long does it take to do these measurements? I think it takes like 10-15 minutes. So I think we're just going to probably do a full sweep of measurements and generate new data and just make sure that everything's matching up. How does that sound, chat? Does that sound thrilling? So, why scrape the bottom? Does it matter? So that matters because that bottom actually has 2 large patches that are maybe like 20 centimeters by 40 centimeters that actually mates up with the base that is equally heavy and rigid as this part of the lathe. And effectively, I need to make sure that those mate up well because, once again, it's kind of like the 3-foot issue. In that case, there's actually 6 bolts that hold it in, so there's like bolt, 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 and then 2 bolts at the front. And effectively, I don't want to introduce an artificial twist into this lathe bed, which is very easy to do if the feet aren't perfectly flat. So effectively, over on the lathe base, I think base is the best term for it. I'm gonna take you for a little quick ride over to the lathe base. Okay. So here's the base of the lathe. Let me move some of this stuff around so it's easier to see. This is pretty heavy, isn't it? Yeah. Shit. Okay, I'm gonna set the camera down and I'm gonna clean a little bit off the this lathe here. Set this on the mill. This on the mill. Okay. And that. And this. Okay. This. Move. All right. So here is the. Let me turn this around. Oops, other way, so I can see better what I'm actually showing you. Turn on the blue. Okay. So this is the actual base of the lathe. I imagine that it's probably twice as heavy as the bed of the lathe over there. So here's the lathe. It's a 1943 Monarch 10EE. So this is quite old, almost, what is that, 80 years old? 82 years old if I'm doing math right. And it's been converted into a VFD, into a variable frequency drive so that it can run off single phase, which is important because I don't have 3-phase to my house. And here you can see where the lathe bed sits. So there are 4 holes here where bolts come up from the bottom and bolt into threads that are threaded into that underside of the actual lathe bed. So effectively, kind of all of this area here makes contact with the base of the lathe. Now, in reality, only the spots around the feet make contact, and you can see that those are scraped. Those would have been originally scraped from the factory. I don't know if you can see any of the scrape marks there. They're quite hard to see. But these feet spots are really what is the precise spots that have been worked on. But my plan is to just kind of make everything flat so I don't have to like it's very hard to make very local areas flat, in my opinion. So I'd rather just come over here with my master square and blow up the whole thing and kind of make that whole area flat. Then here's another contact point. This is for the long end of the bed, and here's where those two bolts go into there. And once again, there's kind of this flange around there. So my plans will be to pick an arbitrary position for the lathe. So this whole lathe is sitting on 3 feet. It's very hard to see them, but this whole bed is sitting on 3 feet. So I'll basically find the nearest plane for this existing stuff, and then my goal will be to scrape in all of this into one flat plane. Then I'm going to scrape in the top part of the bed of the lathe, these flats that we're working on now, flip it over, then once I've leveled it underneath it, then scrape everything to 0. And what I should have is flat underneath here, so one plane underneath. That will mate up with the one plane over here, so that will sit perfectly flat. And then the bed is parallel to the base, so in theory, all 3 of those planes will sit perfectly parallel to each other. So 2 of those planes will be contacting each other, and then one of the planes will be effectively parallel to the base, and it will inherit that, inherit the position from the base. So that is effectively my strategy here, and I haven't fully thought through yet how I want to handle the inverted V's. So you'll see that there's these V grooves. These are also critical features that need to be perfectly straight and flat and in the same plane as everything else. I'm going to have to build some sort of jig or tool so that I'm able to effectively work on making those perfect and in the same plane, but I haven't decided how I want to do that yet, and it doesn't matter at all yet, because I can just work on everything else first, get all those 3 planes in agreement, and then I can worry about the V's, because that would be the only thing left. So, yeah. That thing defeated the Nazis. Yeah. Yeah, I don't know what it was originally used for, or what it was originally manufactured for, but I imagine it had to have been military. I don't know what else manufacturing you would have been allowed to do in 1943. So, alternatively, one could bolt down the top part and then scrape it while it's under tension. Yeah, so that's kind of originally what I was doing. The problem is that this top part is so hard that my intent was that I was actually going to find the nearest plane and then scrape in underneath so that I could minimize the amount of work that I have to do up here. Now that I have the new level and I've been able to image the lathe bed and I've been able to do those measurements and make that graph to determine how much time it takes to basically affect this via scraping, I'm pretty happy with just leaving it as is, going at it here, making everything parallel. So my view, and the reason why I'm kind of scraping more than I need to, for example, up at the top of the lathe here, this head area where this hole is, this area actually doesn't make any contact with the spindle of the lathe at all. The spindle is actually mounted by four little patches, so it will have one spot sitting on this V, one spot sitting here on the V, one in the back here, one in the front here. And the design is that you just only scrape those 4 spots until the spindle is parallel and running concentric with the rest of the bed. However, my view is I really don't want to have any like low or high spots or anything, because the more you do stuff like that and you have like an intentionally like, oh, only these 2 spots are straight down, well, now you have high spots potentially that don't make any bearing contact, so they don't actually affect the performance of the lathe. But what they do affect is the ability to come back in and do measurements with a straight edge. Let's say, for example, that this was all raised 1 millimeter high here. Now I can't come in with a straight edge and see you know, where all of the spots are, because I would have this artificial bump here. It would be okay if there was a hole here and I wouldn't mind too much, but effectively I just want to get anything that is clearly for 80% of the surface it's supposed to be in the same plane. I'm just gonna make it so 100% is in the same plane. It just gives more reference points. And another nice thing about scraping areas that don't actually bear on anything is that 50 years from now, when someone takes the headstock off, this area has never been used. It's not even a contact foot for the headstock. So it gives you a reference point, like a pretty large, like 6-inch reference point that has never come in contact with other material, and it allows you to use that as a reference point of where the wear is on the rest of the machine. So I think there's just nice benefits of just having everything be flattened in the same plane. Yeah, it probably is going to increase the amount of work by 30 or 40%, and I could only do the areas that I need. But I think there's just valuable information in leaving unadulterated reference surfaces for the future. So that's kind of cool. What will this thing be used for? This is just a lathe. It's just for turning parts. I have no use for it other than just being able to make circular parts that you would make on a lathe. I just want it to be extremely accurate. So, okay. So, now, this is actually where I get to hang out with Twitch chat. I'm going to spin up my software here. So I have software that connects into this level. And what this software is going to do is, let's make sure, move level readings, pre-stream.log, Vim level 2D. I think this outputs to, yep, level readings.log. Okay, so I currently have nothing. This is going to start a new log. And so what I do is I get to go through this, and when I hit A on the Xbox controller, it takes a data reading. I can also hit the spacebar on the keyboard. Kind of depends what I want to do. So I'm going to make sure that these flats are cleaned off. So right now there's so much wear on the surface that honestly even getting it perfectly clean just doesn't matter that much. Like my surface plate, it matters a lot more because the only deviation there's a 3mm hole in the surface plate. But this, we have high spots and low spots that are probably like 30 micron apart. So really, super small details aren't the most important thing. Really, we want to just collect this data as fast as we can. So I have this set up on the first spot, on the first dot here. We're going to let that settle. It's been resting on the lathe, so the feet should be roughly the same temperature. And now I get to run my software. You should see some blue light show up there. That means it's connected. And now on the other screen, it is printing the readings that I get in real time. So I basically get like 3 readings a second. It's a little bit more information than what you have on the screen here. I get like 1 more sig fig. I don't know if it's necessarily the most relevant sig fig or not. But I get like 1 more sig fig. And so you can see that when I move around this lathe, I will affect this reading. And that's really just my weight on the concrete basically affecting the whole base of this concrete. So what's important to me is that I'm going to go over to my computer and I'm going to stand roughly here every time I make a measurement, such that I'm basically normalizing my own movement and the position that I'm in, and effectively the mass distribution on the concrete here. In reality, it'd be best to like take the readings off of a separate piece of the concrete where there's a crack and they're more separate. But for right now, once again, we're not actually measuring that precise, just because the lathe bed is so warped that small little details like temperature and me moving around just doesn't really matter. So now I hit the space bar. That's going to tag data. And effectively, I'm saving all of this data as I'm going through at all times, right? And so I'm kind of seeing everything settle in, and I wait until I have a full page, which is probably like 10 readings that are consistent, mark the data again, and this means that in post I can actually go and see all of the readings that were there in case I make a mistake, you know, take a measurement wrong or something. I can go back in post and see all of the raw data as it's streamed in. But other than that, I'm denoting the position that I'm in by every time I hit space. Based on my measuring methodology, I know every time I hit space, I've moved the level 2 centimeters, right? And now we're just doing this. I think there are like 40 points. So we're on like point number 5 now. And we just do this kind of all the way through. But about halfway through, when we get to kind of the most 0, 0 point, not using the controller, there's no reason to right now because I have to stand in the same spot. But I use the controller when I'm like on the ground and I'm like scraping things and I don't want to bring the keyboard around. But right now, it's just plenty easy to go and hit the space bar. But the controller is hooked up. I could just go and hit A. But yeah. Yeah, the nice thing about the keyboard is it kind of forces me to go to the same position every time. Not that it, once again, doesn't really matter at the level, the quality of measurements that we care about right now. So then once we get to a pretty 0, 0 position, I'm actually going to explicitly Sharpie, take a marker and mark exactly where the feet are, because that is the position that we're going to be using to find the nearest plane. So we're almost getting close to the hole here. Here we go. There we go. But yeah, it's really easy to get high quality data here. This level is just incredible. The amount of time it takes to get these measurements, it's insane. Because doing this with the spirit level, it takes so much longer for it to adjust, and it's not two-dimensional. So we're getting close to, I think what I'm going to use is the 0 point, which I think is going to be this next data point, is probably, actually, you know what, we'll use our 0 point as more in the center of the lathe. Once we're over kind of the center of mass. But there you can see kind of that hole that we scraped in, and now you'll see that that X number is going to start going back up now that we're getting past the hole that we were in. So, here we go. Now we're starting to get out of that scraped patch, so you'll start to see a much larger deviation. I don't know how readable it is right now. I imagine it's like passively readable, but not great. And we just do this until we get to the end of the lathe, and then I'll generate a new image for us. Might have to go inside for that, but that's actually okay because I have the computers all set up so I can transfer over to that. Although I don't have a microphone set up on that computer right now. But yeah, we're just going in. Getting this roughly into where the dot is, taking a measurement, just repeating that process. So, pretty boring, but this is quite fast. Given the quality of these measurements, like just one sweep like this is probably enough to be the final pass. Like when I do the final measurements, when I'm happy with all the work that I've done on the lathe, and I want to verify my work, this is probably roughly what I'll do. And it takes maybe 20 minutes. It's fast enough that I can reasonably do this every day to make sure that I kind of am in the correct orientation every day. Okay. So we're almost at 0 index point number 20. And that's what we're going to set as the 0 point. So the way that we're going to do that is we're going to go into this measurement. We're going to make sure that it doesn't deviate too much from the last one. Yeah, I think the measurements are roughly stable here. And then I'm going to mark this data point, and then I'm going to go in there with a Sharpie, and I'm going to explicitly mark where these feet were. Because once we find that the adjustment we want to do to the level to find the nearest plane, this is exactly the spot that we will set it in. So I'm marking a circle where all of these feet are, such that we'll be able to line this back up in this exact spot again in the future. Okay, I'm happy with that, and the reading hasn't changed. It's changed just a little bit, but if I stand over here, it should go back to the, I think it was 2575 when I did that. Okay, now we continue. Now we just go to the next point. So now that will be, basically we'll get, our software will spit out an adjustment factor that will tell us how much to adjust the level of the lathe, and we're going to adjust it for those points. Okay, and off we go. But yeah, this is amazing how fast I can get these measurements. Making decent measurements of the lathe back with the old spirit level, it'd probably take 2 hours, and that was way, way, way less sensitive. Because the level I was using was 50 micron per meter per division. And you can see right now, like, all of these measurements that we're taking are effectively within one division of that. So, but yeah, this lathe bed will very likely be the most accurate surface in my garage once we're done with it. It will likely be more accurate than my surface plate, although cast iron, which is what this is made out of, is way more sensitive to warping due to temperature. So I will be curious how stable it will be once we finish the work. And I'll probably do measurements in various times and seasons of the year and just see how much things change over time. Yeah, so just sweeping through this data. And then maybe I can SSH into my desktop so I can just generate the new graphs over here. Can't remember if I have those pulled down or not. If not, I'll have to go inside and maybe set up a temporary microphone or something. But yeah, you can kind of see roughly how much these readings move around. And they move around quite a bit. I feel like from each point to each point, there's reasonably, 10 micron per meter differences on each of these, and they stay very stable. So once I get it in position, everything's very stable. Things reproduce quite well. Did you use the controller yet, or explain it? Literally, all it is that when I hit the A button, it marks the data so that I know that basically I'm just bookmarking a specific data reading. And I can do the same thing with the space bar, which is what I'm doing right now. The controller's just nice when I'm moving around a little bit more, but right now it's easy for me to just return back to my computer, put my feet in roughly the same position so I don't end up affecting the measurements. So now I can have you come down here a bit more, and you can get a little bit more of the real experience. Alright, I'm gonna wait for this to settle, just because I moved around. But yeah, just my movement is probably like 2 micron per meter of impact on this, which is, what is that, like 500 nanometer or something, like, of actual effect on the feet. Okay. I hope I've pushed the latest software. I can pull that down, but maybe I haven't. I see the machine legs he made. Yeah! Yeah! Aren't those sweet? It's wild to me that this lathe bed is not moving much. I kind of expected it to fluctuate by like I don't know, 50 micron per meter, just settling. But these feet feel really, really rigid. I feel like I'm consistently getting the exact same measurements every day that I come out here and things aren't moving around much. What's the distance between measurements? Looks like 20 millimeters. Yep, it's 20 millimeters right now. So the feet are 190 millimeters apart, and the feet are 24 millimeters in diameter, with like a 2 millimeter thick wall. So, yeah, I'm really happy with those feet. They're the first things that I've really welded. But the actual, I drilled a hole in the plates, and then the metal goes all the way through the plate. So technically, there's like, even if for some reason the welds were to fail, it still goes. The rods basically are making contact with the floor underneath. So, really, my concern if the welds break is that these would start becoming less stable and be easier to wobble and fall off. So, the base is really just for lateral stability. All of the vertical load is transferring almost directly through. So, is the temp consistent between daily measurements? Not really. I don't have a good thermometer. I feel like measuring temperature, I've never successfully measured temperature. It's one of those things that feels really, really difficult to measure. But it's probably within 3 degrees Fahrenheit in this garage, kind of at all times. But once again, for the measurements that we're doing right now, the amount of distortion on the lathe, with the amount of distortion on the lathe, it just shouldn't matter. Like, temperature effects just don't matter yet. Because we're measuring, like 40 micron deviations in the surface here, and the temperature effects are probably going to be in the, 1 to 3 micron territory. So, they should matter eventually when we get the lathe perfect. But right now, the peaks and troughs are just so far apart that it just doesn't matter yet. It would just be a waste to do that effort. But yeah, when you calibrate a surface plate and stuff, you will have a thermocouple usually attached to the plate, just so you can make sure that you are marking the temperature. Like the calibration plate that is associated with the surface plate has the temperature when the calibration was performed. So, yeah, I don't know what the thermal expansion is on granite. I know it's quite low. For my small granite surface plate, I don't think reasonable temperature differences matter. How does the level work? Does it measure orientation relative to center of Earth? Yeah, effectively. So, it has been adjusted to the local gravitational constant for my area, but from my understanding, the way that it works is there's a pendulum inside of a vacuum tube, there's basically a solid steel or something vacuum tube, where there's a pendulum inside, and then there's a laser that's doing interferometry on the pendulum to basically detect the amount that the pendulum has swung, right? So, just getting all those components is difficult. Yeah, the local gravitational constant does matter for this. I've never computed how much it matters, but the manual actually has the formula that is used to perform the adjustment. And my local gravitational constant is quite different from the standard 9.82. I think it's like 9.80 something. Local gravity around Earth in reasonable human locations actually fluctuates by 1%. Obviously in mountains and crazy areas you can get way different readings, but where people roughly live, there's probably a 1% difference in local gravitational constants kind of across the world. It matters quite a large amount. Okay, so we just finished that sweep. We have all the readings. I'm going to return this back to the surface plate, and I'm going to make sure that it's reading the 0 that I expect it to read, basically making sure that nothing is drifted in the level zeroing. That returned right back to 0, and thus I'm happy with those readings. So let me see if I can grab that software quick off my desktop, otherwise we'll have to hop over. So, Explorer. I'm going to save this file, level readings. We'll call this level readings underscore on stream. Okay, so now we've saved a copy of that data. Okay, SSH. I think I have SSH turned off inside. I do. Okay. So what we'll do is, I think I'll just bring the camera with temporarily. So I get the microphone. We'll just pull it on battery, and then we'll go over to the desktop, and I'll be able to actually stream the desktop properly. So really, I'm just bringing the camera with so I get to keep the microphone and don't have to set that back up. Okay. So yeah, you can see the level has returned back to 0. Surprisingly, that surface plate has stayed very much in the same spot. I previously had plastic leveling feet, plastic and rubber leveling feet, and those leveling feet, I think just the rubber and plastic would slightly deform and just cause there to be pretty significant differences in the level from day to day on that. Hey, S'mores! Who's a good boy? Who's a good boy? Yeah, you're a good boy, S'mores. You're a good boy. You're such a good boy. Shit, I hope I still have a Python server set up there. I might not. I do, thank God. Okay. So, now I can go over S'mores. Careful, Bubbo. He's gonna get the lens all dirty. Okay, media source. I just need to rescale this and the desktop will show up. Fuck yeah. There we go. Okay, so, man, this font doesn't have a bold, which I think is going to be really bad for streaming. Whatever. Okay, CD into machining, and this is Simi, I think is what this is. And what I need to do is I need to update the data that we're using. Data. Oh wait, no, that's not Simi. We're in Solver. And let's go in and adjust it to the new data. That's the scrape test data. So this is 2025, 0102. This is stream readings. Okay. Data. Let's copy this. Stream readings. Copy downloads. Level readings on stream to data. Lathe readings 2025. Level readings.log. Okay. And now, I think if I just run this, it should try and solve it. So I think it will go to 45. So we'll go to this screen. Yes. There we go. So I intentionally actually start with like really fucked initial planes because I'm intentionally making sure that my software is converging these to the same planes. So you can see the hole here, right? So this is the hole that I intentionally scraped in. You can see that it hasn't really found the minimums yet. So what it's doing is it's first minimizing. It's minimizing for these 4 scores, and I know they're going to be really hard to read. But the first score is the average distance in micrometers between the points. So we're trying to effectively get all of these points to line up with each other and effectively, connect each other. The next one is the next one is the range from the lowest point to the highest point. So we can try and minimize that. And the way that gets minimized is every iteration, I have like a random chance every iteration to randomly mutate the, like an overarching slope adjustment. And it's trying to find, effectively that is what we are going to be applying to the actual lathe itself. So those adjustments are right here. You see the X adjustments and the Y adjustment, and both of those are in millimeters per meter. So it looks like, effectively, I want to adjust 6 micron per meter in the X-axis, and about 25 micron per meter in the Y-axis. So you can see that the data is converging more and more, and as it converges, we just get a better idea of like all of these, basically all 16 of these readouts are completely independent runs. And the goal is that if the data was inconclusive, they would converge to different local minimums. And since they're all converging to the exact same shape, that makes me believe that my measurements are conclusive, and there's actually a solid measurement here that they're converging to. So yeah, everything here seems to be converging nicely. Is rust a good tool when the problem is purely stainless steel? Yeah. So yeah, here we see the adjustments. We have roughly 6 micron per meter on X and 26 on Y. This is a crazy way of doing metrology. It works, I guess? Yeah. I don't know, I feel like it just is way more visible than just like trying to keep the state space in your head. Because this is kind of what you do in your head is you like go through, normally you do the steps in the increment of the feet sizes. But you can see that the hole that I made, and the hole is supposed to transfer like this point, and this point are roughly all supposed to be the same. Now the hole that I made is probably a little too small for the foot size that I have, because what I'd like to have is like 3 data points that are all in the bottom of that hole. But in reality, that hole is such a small point that really only one reading is actually observing that. You're averaging over a bunch of digital measurements? Yeah. Yeah, effectively, really the only thing that this software is doing is it's emulating 3 points, right? It's emulating the contact feet. It's setting a required slope for the X and Y of the plane that's formed by those 3 feet. And then it's just trying to get close with its neighbors, so whenever those feet overlap with other feet's measurements, it's just trying to minimize the distance between those points, because the view is that when the foot is sitting, like these 2 readings that have massive overlap, in reality those 2 points are probably effectively the same. Yes, there could be a trough that's smaller than the foot, but we're not even measuring that in the first place, right? We're only measuring things that are the size of feet in the first place. So any frequency that is a higher frequency than the width of the feet anyways, we can't even sample that data. So all of these are converging, makes me feel like the data is good. This also lines up with how things feel in real life. And so what this is telling me is we need to take 6 micron per meter off of the X-axis, and about 26 micron per meter we need to add to the Y-axis. So this software is always outputting the image every time we do that. So now I can go and upload that most recent image to our Discord. If you haven't joined the Discord, you should join our Discord. I'm going to upload this to the metrology channel. And this is the surface plate. Nope, this is screenshot.png. And this is data taken 2025-0102 on stream. And then I'll even upload for nerds, I'll upload the actual data file and the file that is used to generate it, if I've pulled that down recently. I think I have. I think that is roughly the right thing. So you know what the data format is. It's a very simple data format. It's literally like 64-bit double timestamp, and then it's the 2 readings of the feet, although you have to transform them into their actual readings. So let me just do a git status, git add data, git status, git push, git commit and added stream data, git push. So there you go. You can literally run that software yourself if you want to play with it. All of the readings are there. There's historical readings. Literally everything you need to play with the software is there. The only thing is that the actual like level foot readings and the methodology for how I got those readings is kind of all just written in code. But yeah, so now I need to go look at how I do the adjustments. I think I call them skews. X skew and Y skew. So X skew and Y skew, we randomly mutate them by adding 0.1 micron per meter to them. If we're doing a skew mutation, then we don't mutate any of the measurements, because the measurements are mutated here, so we only adjust the skews, and then we just recompute basically the errors and minimize for that error. And we recompute. When we recompute, we pass in the skews. And recompute, we take the angles and we add in the skews. Now, does that mean that we need to subtract off or add the skews to level everything? And I think we need to subtract them. Right? Because I am basically faking all of the data we took. I'm adding an additional skew, and in this case we're adding like -6 micron per meter, which means that to get that same reading, effectively I need to get the same readings after the skew, right? I need to actually adjust the physical level to match those, right? Which is, yeah, I mean, we need to subtract them off. Or we need to display those level readings, and then set the actual readings that we get in real life to match those. How hard would that be to add that? Okay, goes to here. How would I display that, chat? S'mores is already passed out. Oh my god. He is cooked. Okay, where are the measurements? Tired of mine already. Yeah, he was already kind of tired when I started streaming. This approach to programming reminds me of my physics professor. The monkeys on keyboard. XQ, YSQ. Yeah, I mean, this software is really shit. It's not meant to be high quality, mainly because I've rewritten it like a million times, and I know I'm going to keep rewriting it. Because in reality, the correct way to do this is gradient descent, because gradient descent would actually work fantastic here. I would do gradient descent from like a very randomized starting point, such that if there are many local minimums, that hopefully you would see deviations. But I just do randomness because I feel more comfortable with it not getting stuck in a local minimum. Even though it still does, but okay. Really all I'm confused about is these skews and whether or not I want to subtract off the skew or add on the skew. And I think I want to subtract it off. Because this is adjusting the internal angles until they have the least amount of effect. And so I need to make the readings match these readings, and the way that I match these readings is by subtracting that off, question mark. I don't know why I'm like so confused on whether I want to add or subtract it. Or do I want to add it because that's what I'm already doing? I really just want to display the actual measurements that are being used when I render. Measurements.plane. Measurements.last vowels. I think last vowels is where I store the skews. Or do I not? What the fuck is this? Recompute. Angle X. Oh, I don't set them. I only use them in recompute. You still do exploit development or bug hunting? Yeah, that's all I do. I don't, I don't really plan on branching out. Like, most of my interest in machining is to make jigs for, like, basically hacking ICs. I want to make, like, extremely precise and sensitive imaging and, glitching tools so that I can... Effectively, I want it so that I'm not concerned about getting code executing or dumping code off of anything. Then that opens me up to looking for bugs in, like, fucking ROMs and shit, which would just put me in a very exclusive league in terms of, you know, you're not really competing with anyone for finding bugs in that. So it's still very related to extremely long-term goals of work. And obviously, I don't need to, like, have lathes at this precision, but I'm learning along the way, and this is literally how I learned how to write code, is the same way that I'm kind of working with stuff in the garage, and I feel like it worked pretty well for me learning stuff in the coding world, so I'm going to apply it to this, and maybe it will work out. Maybe it won't. Maybe I won't really learn much, but I don't know. It's, I don't know. I've wanted to build an electron microscope for like 10 years, and I don't want to build an electron microscope by buying a bunch of vacuum chambers and buying a bunch of vacuum pumps and assembling them. I want to literally build all of the components. I'd love to even build the vacuum pumps, although there's a good chance that that's just going to be slightly out of the realm of what I can do in the home shop. But definitely all the chambers, all of the, like, positioning tables I should be able to make. I should be able to make, like, jigs for holding lasers, so I can do, like, interferometry to basically make sure that I know that the chip is being held in the same positions, stuff like that. So, I don't know, it's something I've always wanted to do, mainly because my view is that when you know how to build the things, you know how to specialize those things. In the same way for software, like, the more and more that I age, the more I realize that my software isn't particularly fast, What's fast about it is that I know how to write the libraries that most people would use, but instead of writing them for the generic every user, I know what actual things I need from the computations that they're doing, and more specifically, I know what intermediate values are being computed during those libraries processing my data, and I know, like, oh, I've already computed the centroid of this data. Oh, I've already computed the mean and median. Whereas normally when you'd be using like high-level software, you're going to end up jamming it into some function. You're going to pass like a massive matrix into something, and it's going to like recompute the average, the centroid, adjust all the points, do all sorts of things, and then you're going to leave, you're going to get whatever data you wanted out of the API, and then you're going to pass that matrix into the next API, and it's going to do the same fucking shit again, but do a slightly different final operation. So you end up recomputing a bunch of stuff, and in reality, maybe the way that you're mutating data or you're taking measurements means that you could incrementally append that data. Maybe you don't have to just recompute the whole matrix. Maybe you can adjust and only recompute the points. And effectively, unless you're working with the low-level actual operations, you don't really get control of those things. So vacuum seals are such a pain in the ass. Yeah, I'm so excited to do that. Like, my view is really the benefits of precision are being able to make, like, reproducible moving parts. For example, making it so you can have a chamber where you can lock off the chamber and then remove the IC while preserving a significant portion of the vacuum. Put a new IC in, or adjust the IC, or remove a layer of the IC, or do something like that, and then put it back in, remove the airlock again, and basically be very close to the vacuum that you need, because achieving the vacuums that you need for a lot of this stuff can take like 30 minutes plus. Obviously, existing equipment already does that. Like top of the line, like electron microscopes typically will already have a separate chamber so you can do stuff like that. But can I make that an even smaller chamber to decrease the amount of time? What if, since I'm only ever imaging ICs that are on an already lapped piece of silicon, what if I can get a semi-decent seal with that? Or what if I can get the IC so close to a super thin piece of glass or a quartz or something such that what if I can image it outside of the electron microscope, so I can bend the actual beam and everything, but it's like only out in the normal non-vacuum space for 1 micrometer in the first place, such that maybe it doesn't matter that I don't have a really high mean free path in air because there isn't much air, or maybe I lap the actual IC and I can ring that IC to the glass, and now I don't have to worry about the vacuum, and I can actually start imaging shit outside of a vacuum because it's on a lapped and rung surface. Like shit like that, right? I don't know. There's things I really want to experiment with. And I feel like that's just fucking science. It's just trying shit out. Like, I don't know. It's interesting. And yeah, is it gonna be a faster way to get to the same things that you could do if you just fucking buy off-the-shelf stuff? Of course not, but it's the path there. I mean, what if I find that there's a really convenient technique for imaging ICs or some shit like that that requires specialized equipment that isn't off-the-shelf electron microscopes, right? I don't know. Okay, so I take the angle, the raw angle, and I add the X skew. And then that's the angle that I have in software. So I need to add that skew. To all of the measurements that I have, I add the skew, and that gives the internal measurement that it's actually using in the software that it's happy with for minimizing that plane and minimizing the... Effectively, what I'm minimizing, the first thing I'm minimizing is the distance between the points, and the second thing I'm minimizing is the range from the highest to the lowest points. And that's what the skew is doing. The skew is basically trying to find that minimum high to low distance, and that's done by just randomly adding a plane onto the measurements. So, okay, so now that we have that data and I've sent it off onto Discord, I can now go back over to the other computer. Oh yeah, let me give you the GitHub repo for the software that I put everything into so you can play it along at home. So I'll post it into the Discord and into the Twitch chat, but this includes the data. You should be able to just cargo run release it and you will literally get the exact same output that I'm getting over here. So it's cool that I'm checking in all the data so that, you know, a year from now when I've been using the lathe, there's some shit that I can go in and actually see this. So I'm gonna go and set up a simple HTTP server. Actually, you know what, the data I posted in Discord is converged, I think, thoroughly enough. Yeah, I mean, what's the average? It looks like I need to go -6 micron on the X and add 26 micron on the Y. And that gives me the reading that I want to actually get. So what we're gonna do is we're gonna go back into the garage. We're going to set the level up on that point that I specifically put the circles on. And then we're going to go and make sure that everything lines up. All right. And I'm starving. I need to order some food. Actually, I'll probably go out for dinner tonight. I found a new bar in town that I've really been enjoying, but I've been on a diet, chat. I'm trying to lose like 30 pounds. I'm a little bit heavier than I want to be. Hi, S'mores. You're a good boy. Have fun, Bubbish. Yeah. Yeah, we're gonna go back into the garage, okay? I love you, S'mores. You're a good boy. Do you need any food or water? Let me check. You have water and you have food, and you've got a little bit left in your puzzle feeder. Okay, S'mores? We're gonna go back into the garage. You're a good boy. Very proud of you. Very proud of you. But I do need a snack. I'm just gonna grab some saltine crackers and some peanut butter, and I'll just put some peanut butter on some crackers. How does that sound? How does that sound, chat? Just gives me something to snack on, because I want to keep streaming, but I am starving. This should fit all the crackers. But yeah, how does that strategy sound? Oh, S'mores really likes the saltines, so I'll give him a couple saltines. Come on. Okay. Good boy, S'mores. Yeah, I'm gonna hide a couple saltines around the house for S'mores. I'm gonna put one here. I'll put one here. I'm gonna put one here. I'm gonna put one here. And I'm gonna put one kind of in his room area. So now he has a couple little saltines he gets to find while I'm out in the garage. Just a little fun thing for him to do, and he already found one. Good boy, Bubble. Okay. Gotta put my boots on. Yeah. I'll leave one saltine by the door for S'mores. How does that sound, Bubbish? And I gotta refill my water. Okay. Saltines. Knife. Good boy, S'mores. Good boy, Bubbo. Okay, off we go. Okay. That. Okay. That is secured. There we go. Alright, let me check in on Jack. How much do you weigh right now? I am like 167 right now. I was 172, and that's when I kinda really got upset with myself. Yeah, we'll just point the camera at the table. We'll just chat with chat for a minute while I kind of eat this snack. How does that sound? So, this way, and we'll just go stand over there. Yeah. So welcome to the new shop. I got a couple new tools in here. I got a welder, so now I have a welder, and I got a bandsaw, so now I can cut like up to like 9 inches diameter of like solid metals and stuff. So that will make it a lot easier for me to buy. Like I don't have to buy pre-cut stuff, because pre-cut materials you end up paying like half the cost is literally just paying for someone to cut it. Can I ask what you're building? I am working on improving the precision of my lathe bed here. So I just have a lathe bed on the floor right here, and I'm effectively scraping it to make it perfectly flat. And so trying to get everything nice and precise and in the same plane, because that is effectively where your tool rides, and your tool is you know, removing material from the part. So the precision of the bed is the precision of the cuts that you're making in your material. Losing weight is tough. I can confirm as a certified dad bod owner, yeah. Have you thought about getting a second doggo? I don't think S'mores would like that. I think he'd get jealous, to be honest. I am like always thinking about it if I do or don't want. Like, I would love to have a second dog. I genuinely think S'mores would just get jealous. The scene is weird? Yeah, I gotta go and update that. Okay. There you go. Sorry about that. How does that relate to exploits? It doesn't right now. I mean, what is physics other than real life exploits? Exploits are just defining undefined behavior, and that's what physics is, right? I don't get people. I have small apartments and work 8 hours a day. Leave a dog at home? Yeah. I'm at home 24 hours a day. I leave my house maybe like 200 hours a year. So let's see if we can reproduce that measurement. And I'm just lining it up the best I can with the Sharpie marks that I made. But yeah, this is measurement 20. So that's 0, 1, 2, yeah. I think this is 18, 19, 20. It should be measurement 20. Yeah, does anyone remember what the measurement was when we initially set it on here? Someone did mention the Keytron in the garage. Yeah, I moved it out here just because it was wireless. I should move it back out of here. It's too nice of a keyboard to be in the garage. 0.13.8, no, it wasn't that. Let me go check though. It was measurement number 20. Let's see. What? Dude, why does Windows have that new absolute dog shit right click context menu? Bring back the old context menu. Holy shit. It's so bad. How many passes do you have to do with scraping to get where we are now? I have no idea. I probably put a couple hundred hours into this, but there's a good chance that I wasn't actually improving things, and I was just randomly, effectively removing things. So, I do think I had a decent reading that one of the low spots was 9 thou. 9 thou low, and 9 thou is, 9 times 25, so like 250, like 225 micron low in one spot. So there's a chance that I've removed like 200 micron from everything so far. But now I can just be so much better with the level because I actually know what I'm doing. Yeah, I need to make a Python script to dump the readings. Dump readings. This would be a great LLM problem here. Is parse fucking take in a structure that is a double and two fucking whatever's integer to angle. Message. So Python does have a new like iter struct or something, like struct iter, that I haven't used yet. Read Ellie nibbles. I don't think I need that. Okay. Gonna do open with open level readings dot log rb dot as fd dot read read 16 bytes, and then struct dot unpack dii, I think. And then that's time, x reading, and y reading is equal to this. Okay. Python dump readings. Okay. Print x reading. there's more data in here. There's a data. What's the format? DII question mark. And the question mark is if it's marked. And if marked, convert these times 23 times 1E3. Index is equal to 0. Print format string index 3. X reading dot 4 F. Still like 8.4 F. Y reading is 8.4 F. Okay. Son of a bitch. Read 17 bytes. The classic 17-byte array entries. Okay, and then index plus equals 1. Okay, so reading 20 previously was 24.9, 76.3. Okay, yeah, it looks like we've maybe drifted a little bit from there. Potentially. So we'll go in and double check those. Okay, now I can read chat. Yeah, we're off by like 6 micron on X. And we're off by like 3 micron on Y, which I think is actually okay. Let's see. Oh. This snack is hitting the spot. How's everyone doing today? What's everyone up to? Did everyone have a good New Year's? Are you going to be streaming for 24 hours? No. I probably won't even be streaming for that many more hours. We're going to probably do a little bit of scraping in one spot. Have you been doing much rock climbing recently? I haven't done any rock climbing in like 4 years. Really ever since COVID and everything like shut down. It kind of got me out of that rhythm. My nearest gym is pretty far away. I could probably search for a new gym, but the gym I went to is probably like 45 minutes to get there reliably. And it's just a little too far. That's interesting. 2 for 9, negative 76. Let's see if that settles in slightly different. It's about the same. Okay. So, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yep, so this is the mark number 20. Just make dumbbells, yeah. I'm not much of a weightlifter kind of guy. I would do body weight stuff. I'd make like a pull-up bar, but I'm not a huge fan of the like weightlifting body types. I like being able to like do pull-ups and throw my body around, mainly for climbing. But now that I don't climb, it doesn't really matter as much. But okay, so I need to adjust this. I need to subtract 0.6 micron from X. Open in browser. I need to remove 6 micron from X and 25 micron, add 25 micron to Y. Okay. Which means that the current data point... Yeah, why are we getting a different reading? Let me re-zero the level, make sure it hasn't drifted. Yeah, I'll clean the feed off of it. Maybe I got some dust on it. Re-zero the level here. Absolute zero. Here we go. I don't know how quickly this drifts. Probably a lot, given I don't have good temperature control in here. Okay. Just want to make sure that our data is reproducing. There we go. We've re-zeroed our level. Reprogrammed. Okay. So the level is happy. Let's make sure that this is clean. That. There we go. Okay, now we're getting... I'll let that settle a bit and let those feet warm up to it. But previously we had 25 and 76, and now we're getting 23 and 81. So I'm happy with that. I think this is good. I lift extremely precise 2.000000 kilogram dumbbells on my perfectly level home flooring. Dude, I'm totally fucking down. That sounds sick. Okay. So, now we need to take the current level readings, which we have 0.024. Let's say 0.025, and that is positive, and then we have 0.082 negative. So 0.025 positive, negative 0.082. Okay, now we need to apply our skews, and our skews are 0.006 negative. So we're going to do negative 0.006 for our X skew, and for our Y skew, we're going to do 0.0257. Okay, so that gives us a target of we want to re-level the lathe so that this exact point sits at 19 micron and then 56.3 micron. And then that should basically mean that the level will be sitting perfectly in that plane, that like nearest plane that we talked about. Okay. And then let me log this. Okay. Hopefully this will output data. There we go. I'm recording this. I gotta go make a quick phone call. I'll be back in like 10 minutes. Okay? I'm actually gonna bring my snack inside as well. I don't need to finish that. Alright, I'm gonna make a quick phone call. I'll be right back. Okay. Now I need to pick some music. I'll do this. Okay, has it moved much? What has changed since I was gone? Nothing. Okay, I'm gonna punch in the actual numbers I got from the software. So we got a 25.7 and a 83.4. So I'm getting these from the actual same software just in case the display differs slightly in rounding and stuff. And then let's go and apply the deltas. And subtract 6 from that. And add 27 point... I think just like 26 is a good adjustment for the Y. And we're going to add that. Okay, so our target now, so we want to go in here and we want to go re-level so that these readings give us 19.7 and 57.4. So in reality, we're going to shoot for 20 and negative 57. Yeah, we're going to go for 20 and negative 57. How does that sound, chat? And then I need just a wrench. Alright, so I think 4mm wrench fits in this hole. We're going to negative 57, so we need to raise this up, which means we need to go counterclockwise. Okay, we're going to 57. There we go. And you can see that affected the other reading, right? So just by nature of doing that, we affected the reading of the x-axis. So now we're at negative 56. We want to be at negative 57, and then let's go. We have to raise. We have to lower the this side here. That was probably way too much. Yep. And we want to shoot for 20 on this. Come on. This level like jumps around a decent amount when it's doing its like averaging window. So sometimes it can be very difficult to interpret. Ooh, I probably overshot. Fuck. I mean, this level of leveling is kind of overkill, but that's probably pretty good. Okay, our goal is 20 and 57, and let me stand over by the computer where I take the measurements. Okay, 23.55. So we're off by 3 on the first one and off by 2 on the bottom one. Positive 20. Chat, I don't know if it's worth trying to perfect this. 23.56. It's really just that X reading, but man, it's so hard to adjust that. We got Los Santos Customs right now? Yeah. Oh, shit, I wasn't pointing this down at that. I'm sorry. Okay. So, I think I'm pretty happy with this. Our target was 19.7 and negative 57.4. And we're at 23 and negative 55. So we're within like 3 micron per meter of each. I think this is good. This is good enough. Okay. Now let's just make sure that it holds that from a little bit of. Let's just give it a little manipulation here. Make sure that it's seated on those feet. Okay. I'm happy with this. So now the lathe is in the orientation of the photo, effectively. So what we should see is that there's a hole. If we go, how many readings in? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we want to go 9 readings in. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This should be effectively the worst measurement on the entire lathe here. And I guess it's really not that bad. So 39 micron per meter. So what is this actually? 1, 2, 3, 4, 5, 6, 7, 8, 9. Maybe like 10? Yeah, that checks out. Okay, so basically, if you look at if you want the screenshot, here's the screenshot again. This is what we're trying to look at right now. And right now, I have this spot, this foot up here at the top of the y-axis. That is, in theory, in the deepest hole in the lathe. So you can see that there's a 0.000 reading. And hopefully we have that foot in that spot right now. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And count the circles. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So effectively, now what we want to do is we want to scrape down. So this is the lowest point, right? So this is saying it's down 39 micron per meter in that spot. So we have a hole right here. And what we want to do is we want to scrape down this foot, right? Because we have to lower this part down to 0. So I'm gonna mark the position of this foot. Okay. So I've marked that foot, and then now we just want to do scraping passes, and we're gonna scrape. We're gonna scrape plus minus. Let's just mark this foot. Okay. Okay, so let's mark these. So what was the reading we had there? It was like negative 40, I think. So we're gonna say, we'll say that this is positive 40. And let's say that this is 0. right? And 40, that actual difference on a 190 millimeter base is 7.6 micron. So effectively, we have to remove 7.6 micrometers from this area here, this little foot spot. So we're gonna go in there and try and scrape that out. Doesn't that sound exhilarating, chat? So I'm gonna use this this block here. I'm gonna set it up roughly in the center, and this is gonna determine how much we scrape. So we're gonna scrape kind of this whole area until we hit that point. So we're effectively trying to transfer the 0 up here down to this spot here. I could honestly try and scrape just that one specific foot. That could maybe be fun. It's just gonna be so hard to do that. So let me kind of wall that off. Just kind of on both sides of that foot. And maybe we'll try to hit just that foot area for now. So I'm just gonna indicate in roughly these different spots that we might hit. Okay, and now what we have to do is we have to go in here and we have to blue it up. So I have a blue spotting ink here and a 123 block, a very nice 123 block. And I'm just going to clean it off with some acetone. And then we're going to apply an ink to this 123 block, which is hopefully very flat. And we're going to use that to mark all of the high spots in this area. And then we'll just scrape it down until we don't have high spots. That's scraping. It's thrilling. So I'll blue this up. Just get some ink on the 123 block here. Now keep in mind, since we are we're using the 1x2 area of the 123 block right now to indicate this. And I'll just set that on there like that. Rub it on top. And that feels like it's indicated quite well. And now we just want to go and hit all of those high spots. So any of the spots that have blue on them, we're going to go in and try and remove them. So let me bring the camera in a little bit closer here. Like here, make sure it's not touching anything. Good. Here we go. Okay. There we go. Okay. All right. Let me read some Twitch chat. Okay. Twitch chat isn't saying anything. Cringe. Cringe. So we're gonna go in and remove kind of all those high spots there. Let me check the graph and make sure that there's nothing. Yeah, that's the spot that we're scraping looks relatively flat. I think we can scrape that whole area that we're in safely. Let me 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I think this whole spot is going to be pretty safe to scrape. It looks relatively flat. There's no particular hole or anything there. So we're just going to scrape all of these spots. So, and now I have to kind of set up a good environment for myself. And I'm going to go get my my knee padding, so I don't end up wearing up my knees. So I do have to do this on my knees, unfortunately, with this setup. but it's not too bad. Wow, this spot of the lathe bed is fairly soft. Okay. This is actually going to be a pretty easy spot to do, given how soft this material is right here. Okay. And I have my square, so this will allow me to kind of clean up that spot. So that's really just trying to deburr it. And then let me go and grab my level and get my level in position here. What are you thinking, chat? We started at, it was plus 40. And there you go, now we're at 22. So let's make sure that's not a... Let's move around just a small amount in this spot, just get a couple different readings from a couple different, like, placements of this. So what this is telling me is that there was only just a couple high spots here. When that much material comes off in one pass, to me, my interpretation of that is effectively that there was a very localized cluster of spots that were high, because I didn't really remove that much material there. But let's continue at it. Now let's blue it up again. But yeah, that was nuts. I was kind of expecting no change. I feel like some passes have no change and some have pretty high change. But that was a very healthy amount of change, IMO. Not happy with that. I'm going to apply a little bit more ink. Since we are doing what I would consider roughing passes, we're not trying to get a fantastic bearing surface here. We're just trying to blue up and take off this material as fast as we can. Okay. And now I'll hit it from this side. Okay. Okay, kind of missed that spot. That's okay. Okay. All right. We want to deburr it, get rid of any burrs. Try and get rid of any dust. And we'll come in here for another measurement. There we go. Okay, so now we went up. Yep, and that means that there's just some localized high spots in there. And so let's just see what we get here. There we go. Now we're still negative 29. So that's kind of more what I expected for pacing. I think we just kind of ended up falling into a hole on that first measurement. That made it look like we made more progress than we did. And that's okay. We come back in, we'll just do a couple passes of this, and we'll hopefully be transferring this hole pretty easy. Now it's important to note that indicating this hole in is going to be difficult. I'm going to have to go sideways, because I need to make sure that I'm marking only the area that we're actually scraping in, because this area is going to get lower than the edges, so when I go sideways, I'm not actually going to be marking all the high spots correctly. So, okay. But yeah, I love scraping. I love the sounds, the smells, the like cast iron when it's like in your on your hands. Yeah, this spot is fairly soft. This corner's a little harder than the others. Okay. There's kind of one high spot in there I missed, but that's okay. I've found that it's usually not worth trying to go and hit all the high spots. If the tool kind of jumped off and didn't hit it, you're usually doing more harm than good to go in there and try and fix it up, because you're going to end up putting two scrapes like right on top of each other effectively if you miss. But that's looking good. It's got a really nice texture on it. Let's try and get a level reading here. Make sure our feet are clean. Going in. Set it in there. Let's see what we get. Alright, there we go. We're at 12. 13. So we're flying through this, chat. This is actually pretty nuts. And as we get towards the end, we'll actually start spending more effort cleaning up this area. But right now, I just don't really care, right? So I'm just kind of going ham in here. Blew everything up. Wow. That is a beautiful pattern. I don't think I've ever seen a pattern that good on the lathe here. Just indicating up really nice, showing me that these are pretty good scrapes. So yeah. Come on. Not at the ideal angle to be doing scraping here. This was not a very good pass, but we're gonna just take what we get there. That's the beautiful thing about scraping, is you're getting rid of the high spots. If you missed one, it'll just show up the next time. Get that deburred. Wipe it off. Okay, let's see what we got here. Okay. Alright, we're reading -11 still. That's totally fine. Just means that probably didn't hit the high spot, or it's just a slight translation difference on where we placed the level. So once again, we're not trying to be perfect here. We're just trying to transfer this lowest point to other points of the lathe bed, just so we'll be able to get this reference point kind of throughout the lathe. That's a good indication. Beautiful. Great. Okay. Okay. Alright. Not super happy about that pass. Sometimes you just don't get the sometimes the scraper just doesn't really go in in the shape that you want it to go, or in the path you want it to go. It gets steered pretty easily by what's kind of on there, which is always really interesting to kind of feel. You feel the surface, even though these imperfections are so tiny. You can feel all the individual marks pretty easy. It's kind of nuts. Okay, set this back up, and there's a chance this is the end here. Nope. Nope, effectively no improvement there. So now let's just go and make sure we definitely have that cleaned off as well as we were hoping. Make sure that our feet are clean in case our feet are dirty. Okay. And there we go. I think we just had a little piece of dust there. So I think we're going to try and bring this all the way down to 0. So we'll do one last very light pass. And we'll try and put some extra care into the quality of this scraping pass. Because then we'll be transferring this to the other side of the lathe. Actually, we probably should stop here. Because where are we going? Because we have our y-axis we've adjusted down. So this spot should roughly match this spot in terms of elevation. But this spot is very high. This spot is extremely high. And in theory, could slightly be affecting this reading here. What we're hoping is that this whole thing is we're going to just pull this plane down in this direction. But that's not necessarily going to be the case here. So we're going to go over here and we're going to start scraping under this foot. We've got 128 to go. You can see that we did like 40 here pretty fast. That was maybe 5 passes. Surprisingly fast, if I do say so. So we're going to mark the area that we're making contact with over here. Yeah, we'll go fairly tight. And yeah, we're going to just stop in this area because there's a chance that this whole thing comes down a little bit as this comes down. Probably not really too much, but there's technically going to be some effect there. So we'll start indicating in this spot now. So this area of the lathe is way, way harder. It's a lot harder to work on. You can see kind of how big those blue spots are. And that's really because getting good scrapes on here is very difficult. And that kind of leads to kind of those bigger areas. You're going to see the tool is going to like kind of jump pretty fast over those spots. It'll get like stuck and jump over. So you'll be done with this in only a few months. Yeah, it's a very slow process, but it's pretty fun. I mean, you just put on some music or an audiobook and go to town. Yeah, it's so hard here. So I'm going to try and do extremely heavy passes because we're trying to remove a lot of material now. There's no reason that we have to be careful. Yeah, you can see how this behaves a lot differently over here. And it's just a local spot of hardness because they flame hardened this bed and they flame hardened it by hand. And so some areas are going to have a little bit more soak than others in terms of the heat input they would have put in with. I mean, I imagine they just like literally put a blowtorch to the bed. So maybe I'm wrong. I'm not 100% sure in how that process is done. Oh, I probably should have written down where we started. Does anyone remember what this is reading? But yeah, there you go. Already passed number 1. Okay. Beautiful. So I'm going to say it's 117 now. 117. Just make a note of that. And we're still being fine here, but we are actually coming down a little bit on that x-axis, which is kind of what I was saying, is that I think there will be a very, very small effect of twist as we lower this spot over here. Let's get everything blued up here. But yeah, this like super hyper local scraping, I don't know. I don't know if this is a thing people do, but I think it's a really good way to try to do this. IMO. But I'm also not an expert. But yeah, you're not supposed to scrape hardened surfaces because it's very difficult. So we're solving that with just force. We're literally keeping our blade really sharp. And we're using a shit ton of force. And we're removing a very small amount of material. Compared to if this was not hardened, we would be taking off. With these heavier passes, I'm putting quite a bit of force behind this. These passes on non-hardened cast iron would be pretty deep gouges, but here it just kind of skates across. Any chance that GMS hacking videos will ever get released outside of YouTube? You mean like the software? I probably don't even have that code anymore. But even if I did, I'm not going to release the code for those. Okay. We'll let that settle and read some chat. The Maple Story ones... Oh, the ones taken down? I think I still have them on YouTube. So I could probably download them and like re-upload them or something. Oh, the Maple Story RNG. Oh, there we hit 0. And we went to 106. There you go. And we hit our 0 there. So yeah, as I kind of expected, we're potentially overshooting a bit here. But that's okay. I'm not, it seems like we're kind of taking off like 10 micron per meter, which is probably like 2.5 micron per pass. Some passes are duds. But, yeah, we can try and get this all figured out. So this is starting to blue up a little bit better now. You can see that I'm coming in at kind of different angles here, and that's to maintain a crisscross pattern here. And I really want to hit any of the shiny spots, because the shiny spots, the shiny spots are the ones that were definitely making contact with the 1, 2, 3 block that I'm using to blue it. Wow. Now I'm in a slightly softer spot. I had a slightly softer layer here that's behaving quite a bit different. So, and sometimes they'll just happen due to the shape of the peaks and valleys. It can have a pretty large effect in just the way that the tool feels in there. But yeah, I suspect this will end up being like -10, which means we probably basically added like 1 pass that we'll have to do. But really all we care about is getting everything geometrically stable on the lathe, and then we're just going to be mainly bluing with a straight edge. So, okay, 102, 101. So we basically made no progress that pass, that's okay. And we're back to 0.6, or 6 on the other axis. which is good. It just shows like kind of how much variance there is in our measurements, in our placement, in the cleanliness, right? Like if we have any debris or dust, because we are producing a lot of dust when we're scraping. So the cast iron kind of comes off as a dusty powder, and that can pretty easily throw off your readings. So okay. Okay. But this is just really wild because I'm just learning so much about scraping when I'm able to kind of know what I'm doing. Traditionally, you're not really going to know how much material you're actually taking off. You're really just going for more coverage of the bluing. But we're not doing that here. We're only going for geometry. So we're kind of trying to hit all the high spots. We're not trying to improve the contact patch here. Basically, once we've gotten the geometry figured out on the lathe, then we'll worry about like actually making this a really nice, clean finish with a high density of points. Okay. And then every few passes, we'll also probably need to clean the level, make sure we're not accumulating any dust. Okay. Probably 92, maybe 91. So I legitimately think we're removing like 10 per pass, maybe on average. I think it depends on the quality of scraping. I think sometimes you can have a dud pass where you kind of miss one or two of the really big high spots, or you're not applying the right pressure, you hit something at the wrong angle, and you just don't end up with a fantastic scrape. But it's pretty incredible that I'm able to improve this fast, in my opinion. So right now we're also not making sure that the two sides are, like, in theory, these could be both like pointed down or something and making like a V between them. Right now we're not doing anything to counteract that. We're just hoping that they're already sitting pretty flat, and then we'll that will be a different little tool that we're gonna have to make to measure that. We need a bar that goes across. But right now I just think that should be negligible, and I could be wrong. Oh, yeah. Yeah. That's good. Okay, I'm not going to retouch those. So I'm happy with that. I think that was a pretty deep one. There's a pretty big amount of cast iron coming off that one. There we go, 83. Yeah, I legitimately think we're taking about 10 off per pass, which is about 2.5 micron, right, with that base, or 2 micron, which is honestly a lot more than I expected. We're flying through this, chat. Because we started at 117. Let me, as we lose these lines a little bit, I'm just going to remark them out so I don't lose them. This area is lower, so I won't end up affecting that line as much. Did I come in from the left or the right that pass? Would grinding it in at the end make a good contact patch? Scraping is traditionally preferred for a sliding linear surface like this. The surface finish allows the troughs allow oil to sit in there. Maybe not this, but like a flaked surface. So typically you would, if you have a linear bearing surfaces that's an oiled surface, you actually prefer this sort of thing. You're significantly decreasing the amount of contact, right? Because the contact is only on these points, so you're like having the amount of friction, which affects your stick slip and your positioning of tooling, right? When you're trying to really dial into a couple micron, just the table itself is like grabbing and letting go and grabbing and letting go. So you actually don't want a perfectly smooth surface to kind of avoid some of that stickiness that you get. So but I'm really happy with the amount of information I'm getting. I mean, all I'm doing is just setting a level on here, and I'm learning so much, which I never was able to do this with scraping. Okay, we're reading 91, which seems really high. So we're just gonna clean off our feet, clean off our contact spots. Go in there again. Potentially we left a burr in there somewhere, but my guess is there's probably a little bit of dust on the feet, so I'm actually gonna move the feet around a bit, hopefully knock some dust off on the edge there if there was any. There we go. Okay, now we're coming in at about 70. So yeah, there's probably a speck of dust. Literally probably like a singular speck of dust under there that really threw that measurement off. Or I just hit a high spot with the leveling feet or something like that. So now we're positive, we're now positive 3 here. So we have sunk in here, which is what I was expecting. I didn't know like how much to leave in there, but you can see that I did leave like 6 in there. And we've already used up all 6 of those, so we're gonna probably end up with a little bit of a hole here, but that's okay. We'll just bring this down to match it. So it's kind of hard to predict that until you know what this feels like. And these are some of my very first scraping passes with this level. So I literally do not know how things respond. Also, as you saw, just a speck of dust, or something being a little dirty, or just resetting that level, and we got like 20 micron per meter different of a reading. So it's really important to make sure that that you're trying to get the measurements multiple times and stuff. So luckily with this, since every pass I'm going back to measure, I'll kind of like, maybe worst case scenario is I'll jump over the end because I got a false reading, but usually it's pretty obvious when there's a false reading. Like there, we knew something was off, and so we just went back and cleaned everything up and remeasured. Which is a good sign that you actually are kind of building a good mental model of the surface in your head when the predictions and the feelings you have match up with the measurements. So this is a really heavy pass. I think there's a chance that a decent amount of stuff got cleaned up there. Look at Mose, I haven't seen them for a while. Yeah, it's been a long time since I've strumped. Okay. Okay. Yep, kind of getting a weird reading again. That's okay, we're just going to keep plowing. At some point it doesn't really matter, as long as we know that we're within the, we're not like going over. But right now, until I start seeing like 20s, I'm really not convinced that there's even a chance that we're going too deep here. But I'm actually getting a way better surface finish here. So that's really nice. That contact patch is actually a very healthy scraped surface. Did I come at this from the left or the right last time? I think I am good to go. So every time I'm doing a pass, I'm kind of experimenting with like what I'm prioritizing in terms of what I'm scraping off. And we're kind of seeing if that is affecting stuff. So like right now I'm trying to hit more of the silvery patches, which is where it got blued up, ink got applied, or sorry, the like lighter blue, which is where the ink got applied, but also there was so close of contact that it actually made the layer of ink thinner, right? And that's telling us that those are actually the highest of the highest spots. So I'm trying to manually hit those, which is what you're supposed to do in scraping, but I don't know how much, like if you're doing roughing passes, is that super important? I'm not sure. And these are things that I'm just gonna kind of learn out and feel throughout this entire project. And here I, oops. Yeah, so there I got dust over everything. You can see how much dust is in there. So we're just gonna clean off kind of all of our tooling here. Start fresh. Just because we're building up, you know, debris, especially with this ink. This ink is pretty thick, so this ink will have, it'll let particles kind of build up on it. I should go in here and measure it right now, but I'm kind of already inking. We'll go and measure next. Okay. Clean up our pads. Okay. Yep, so now we're up. Now this is up 8 micron per meter. So we should have left maybe like 30. Maybe I should just assume the ratio is like maybe like a 1 to 4. If I want to remove 100 from this side, I should leave like 20 here so that I don't lose all of that from the twist, is my theory. I don't know. We scraping, yeah. Yeah, this is still how people make precision surfaces. So scraping is still a big thing in like high-end CNC equipment. Most of the beds are going to be a cast iron bed that's scraped in. Obviously they're going to use a power scraper, but I can't use a power scraper on this surface since it's so inconsistently hardened. It's too difficult to apply a uniform amount of pressure here. So it's kind of frustrating from that perspective. You guys kind of out of focus here. Let me bring you into a better spot. I think the camera's maybe been drifting down a bit, or I don't know. There you go. Okay. So, this is actually turning into a very nice pattern here. So if I block some of the, where's the light coming in from? There you go. So it's a pretty good pattern that's coming in. I'd be very happy with this as even the final bearing surface here. So that felt good. And I feel like once you have good scrapes in, the scraper starts to kind of guide you in the right spots. And right now I'm feeling that pretty good. I definitely can feel the individual high spots, which is really nice. I'm happy with that pass. That's probably one of my favorite passes in the night. Yeah, it's really wild how much information there is in here. Deburr that. Make sure it's clean. Now we get to measure. This is the fun part. Did the number change? No. And maybe a 62? Okay. Let's try and do a heavier inking here. Let's see if we can get a little bit more information, more contact patch, or more high spots, I guess. I don't like how much this is rocking. There's definitely a saddle here in this. I definitely have kind of a U shape. Yeah, so that's something we're gonna have to fix up kind of at the end here, but hopefully it's not too crazy bad. But it's very difficult to indicate in such a narrow surface like this when you're just bluing it. So I'll end up having a dumbbell. Honestly, I should probably just go and make that now, so that I can make sure I'm not wasting time. And then I'll actually be indicating in across both sides of the lathe as a rigid structure. So let me show you what I mean here. We'll get this measurement, and then we'll. Unfortunately, I actually don't have V-blocks. We've kind of made too small of a spot here. So the tool that I'm gonna make, we're gonna have to just stick in the same spot. I think this is fine. We're gonna upgrade to the dumbbell that I call it, and the dumbbell will help us keep these two in the same plane and not like angled in or angled out at each other in like a U shape. And it's really just because the distance here, since these are only 1 inch wide, there's so much room for just a small amount of tilt. So we put this across, let it settle. There we go, we're at a 51 and a 3, so we're definitely making progress, right? So like, it's working. It's working. Which is very PogChamp, as the kids say. We open up the Stream Manager. But yeah, it's really cool to see this progress. I mean, it's wild that I'm not blind doing this. But we're actually going to undo a lot of our progress here because we're going to expand out this contact patch to the size of our dumbbell. And let me show you what I mean by a dumbbell. Raise your pogs. Holy shit, I haven't had the camera plugged in this whole time. Whoops. What's the battery level at? Oh, we're at 1 bar. That's impressive. That's been unplugged since we went inside, which is what, probably 30 minutes ago? Maybe a little longer? Man, I love that. And I think this battery is not in the best shape. Okay, so now we're going to build a dumbbell. We're going to do that over here on the surface plate. So what I want to do is I want to build a tool that will allow me to transfer the, let's see. I want to build a tool that's going to allow me to transfer and kind of measure, basically, I want a straight edge, a virtual straight edge, that sits across both of those flats of the lathe. So I need two things that sit 190 millimeters apart. So let's go and measure out 190 millimeters. And we're going to be building these out of V-blocks. So this is the same little dumbbell tool that I built when I was doing the initial measurements with my old level. So here are the V-blocks we're going to be using. And then I have a precision linear shaft. This is a pretty thick, solid, hardened piece of metal. And this should be quite concentric and straight. So let me double check. And I need the straps. There they are. Okay. Grab my 1 micron indicator. And we'll use, so we're going to actually measure in this bar. We're going to make sure that it's, that the bar is straight. And this is what we're going to use to attach the V-block. Let me go get the size of this. Looks like it is 3/16. Yes. So you got a 3/16 wrench, some screws, an indicator, and then we're going to clean all of these things off with a little bit of acetone. So I'm going to move the camera a little bit. Shit, here we go, dumbbell. Yeah, that's what you're talking about. You were asking about dumbbells earlier. So I could move the camera up a little bit. I'm not 100% sure what's going to be the best experience here. Okay. So we know that our surface plate has a 3 micron hole in it. So we're going to probably stay working on the edge here, and that's going to probably keep us within 1 micron tolerances when we're setting this in, which is going to be very good. And then we'll go grab some acetone and a little cloth, and I'm just going to start by wiping all of these tools down in some acetone. Acetone is probably my favorite solvent. It really helps take off those oils and greases. I don't know. Acetone is just my favorite for sure. Okay. Now obviously by wiping this down, we're going to transfer a little bit of lint to it from the cloth. But all of these things will end up wiping down with our hands at the end. Yep, here I can feel there's a little ding in here. And it looks like that is just a little pocket of corrosion. And that's okay, we just have to know about it. We don't have to, doesn't matter if this is perfectly straight. We just have to know where the flaws are. Clean out the bottoms and tops of the V-blocks. And effectively, we're just building a straight edge that has feet that are lowered on the ends, so we can clear the height. We have to clear the height of the inverted V's on the ways. So that's looking pretty good. Let's see how this is hinging. This should be sitting flat on the plate. It's hinging in the center. It's got a high spot on that corner. This is hinging in this corner, so it's got a high spot in that corner. But this is actually kind of ringing to the plate. You can see how that kind of sucks down. And to me, that is telling me that the that's got a very nice bearing surface on the bottom there. So, same with this one. This one kind of sucked when I pulled it up too. There's definitely no burrs on it. Burrs would be very obvious in the, in this. Let's see. Okay. Clean off that bottom with my hand. We'll see if this... So this is hinging kind of in the center around this hole. So I think there's a little raised spot on that hole. Maybe not. That was a false reading. Hinging at the end, providing some suction when I pull it up. So I'm very happy with that. Okay. So yeah, this one has better bearing contacts than this one. This one's not bearing as well on this plate. And you can just feel that through the resistance. This one grips a lot more. You can see that this one slides a little easier. It's hard to normalize the force, but you can see that this one sticks a little bit more, and that's just because more of this base is making contact with the plate. Okay. Now, we put that bar across. I'm going to give it a couple rotations, and this is now kind of locked in these V-blocks, right? These V-blocks now kind of have to move together. If one was slightly offset, you'll see it kind of snaps into place, right? So this is kind of a centering thing, assuming that this is straight. Now, really all we care about is that the bottoms of these are making even contact. And that's going to be very difficult to do here because these straps are going to put some force on this. So we're going to try and strap this down. So, and we're putting these in the center because we want to pull up kind of on everything equally. And we'll see what we get here. I need to not torque these down too much because when you torque these down too much, you're going to introduce some bend on this, but I can still rotate this. Okay. So this is finger tight. So now we can start kind of doing some measurements of what this bar is looking like in terms of whether I'm getting the same readings on both sides. So I actually have a new indicator stand that I got a while ago and haven't really used yet. That's designed to be used on the surface plate. So let me try and keep all this cleaning cloth stuff separate. And that indicator base is this heavy cast iron that's been precision ground on the bottom. Really cool. I haven't ever indicated it, so I don't really know how well that's ground in, but it's obviously done on a surface grinder, so there aren't many surface grinders out there that are completely off. So this, get that base cleaned off. So this is a tool that'll probably end up scraping in at some point, this indicator stand. So let's just see if that's bearing well. Hinging at the end, hinging at the end. Seems like it's making mainly contacts in the ends, but that's fine. It's still making very good contacts, but feels like the center of this is kind of high. It doesn't feel like it's grabbing much in the center. So now I can take this stand and we'll be able to set up an indicator here, and then we can rotate this rod and we'll be able to see if we're getting big differences. So we should have the same absolute heights on both sides here. Right, so we're gonna come in here, move the indicator around to different locations. Okay. Man, it's gonna be hard to read the indicator under this. We could sacrifice some rigidity and use it on the outside. I think we're just gonna suffer through, and then I'll get you in here for a slightly better shot in a minute. Okay. Perfect. Okay. So, I'll reposition over to you guys. So effectively, I can now move this indicator around, and this little needle is staying at the same height, right? Assuming everything's perfectly rigid. And so, I've dialed it in so that when I come in contact here, you'll get to see the curvature, right? I guess you can't really see that indicator. I'm gonna probably have to raise you up here. I hate raising the stand. It's just so much hassle because it's so heavy. Okay. And this one. Okay. Now you're up higher. I can bring you up even higher, but I don't think I'm gonna have to. Okay, so now you can kind of see the dumbbell that we're building here. We have an indicator in here. This is a 1 micron indicator. So each of the divisions on this indicator are 1 micron. So each of those ticks. So, want this to be settling in. It is. And I'm going to go up here and I'm going to sweep across and read for the highest point. So there you can see we made contact, we're sweeping, and there is the highest point. I'm gonna dial the indicator back just a little bit just so you guys can see it. And we're gonna pull across it because I don't like pushing the needle into things, I like pulling the needle. So we're gonna pull the needle back here. And there's contact going up. They're at 20, 30, 40. That's looking like a 46, and it fell off. Okay, so we're at 46 microns. So now I can come over here and do the same thing. And what I want is that this is at 46, and that means that this beam is basically the same height across. Okay, pulling back. There's 44, 47. And we dropped. So those two sides, those 2 points we checked are within about 1 micron from each other, which is fantastic. That's what I remember. So I actually bought, these rods are like 60 bucks, hardened, ground, precision linear shaft. It's a really thick, I mean, even just the raw material here is probably worth like 30 bucks for the raw, like 1 or 1.5 inch, 1 1/4 inch rod. And I bought like 3 of them, and this is the best one of the bunch, right? And it's kind of a decent strategy. So now what I'm gonna do is I'm gonna mark the top of this rod. And we're gonna clock this about 90 degrees, right? So we're gonna flip this over. We could also do like each 45. So yeah, let's just go there. So that's like 45 roughly. Bring this indicator back over. I see a 46, perfect. Consistent repeat reading. That was maybe a 48. Okay. Rotate it again till the X's are at the bottom, roughly. And we'll come back in. I shouldn't have lifted that up, but that's okay. Okay. I've got a piece of debris under it now. There we go. That's better. Okay, 40. This one I'm getting like a 44.5. And then I'm getting a 46. Okay. Okay, and then we'll clock it at this angle. This is now like the 270 degrees. Cross over, come back. 43.5. 44.5. Okay, so we're probably within about 2 micron on this bar. So if you want to think about the accuracy of this bar, effectively, I'm comfortable with using this down to 2 micron, which is pretty nuts. So now what we can do is determine the size of this that we need to span over this base, because we need to go 190 millimeters across here with this dumbbell. So, and I think we want that to be center to center, but let me double check that we can actually do center to center there. Okay, I'm gonna give that, yeah, that's 62 millimeters. That's obviously 2 inches. So we got 62 millimeters, and so we want to go 30 millimeters in. Or wait, did I say 62? Yep, let's say 62 millimeters on that. Divide by 2, so that's 31 on each side. So let me go and mark at 31 on these bars. 31. So I'm just trying to mark the center point. 31. Okay. Now, we want those centers. First of all, I need to make sure that I actually have 31 millimeters of clearance on both sides of this dumbbell. And I don't. I actually, until I hit the flat, I only have 26 millimeters there and 22 there. So I need to have, I need 20 millimeters of overhang on the interior. So I actually need to go, let's just go for, yeah, let's go for, we'll hit 18-ish. Okay, so I'm marking basically 18 millimeters into the inside here. Or wait, it's 18 on the inside on the left side, and then the other side needs to be 18 on the outside. Okay. Because otherwise I run into those, into the V, inverted V's. Okay, so I'm already very close to where I want to be. Bam. Gotta come out 4 millimeters here. Okay, this is 188 center to center. It's 189. There we go, I think that moved. Yep, that's 190. Okay, so now I have 18 millimeters here, and then I'll have 19 millimeters there, and I'm gonna be trying to hit center. Yeah. Okay, so we're gonna lock this in here. So I want to be gentle with this. I don't want to put too much force on these screws. I really just need enough so that the blocks stay in place and in the same plane. And now what we hope is that this dumbbell, both sides are sticking to the plate, which indicates that they're in the same plane, and they are. I'm happy with that. Okay. We can do another sweep here. I think it was 42? $43. So I'm happy with that. I could technically blue this in on the plate and see if it's making good contact. Chat, do you want to see that? You know, blue in the plate and see if it's see if the contact that we're getting off this dumbbell is pretty good. Okay, so we're just putting a little bit of the bluing ink on the plate, which is our reference flat. This will allow us to kind of transfer any of the, we're going to try and transfer the flatness of the plate to this bar and see if we're getting a good contact. And I expect it's going to be the two ends that are making contact here. It's going to be the two far ends of this that I expect will have contact on. Yep, already seeing that, but we actually have pretty good friction here. This is quite hard to move. But I think most of that bend is just from when I tightened that down. So here you can see the contact patch of this bar. So honestly, a pretty good patch. Just a little bit of a hole on each one towards the ends. I'm pretty happy with that. I think this is going to be fine for what we're doing here. We're not trying to really go crazy on transferring this. We just want to eliminate a little bit of the error that we can have by such a local contact point for the tilt. Because if you think about it, like right now when we have a really small thing, think about it as like only this base here on the left is actually being used. You can see how easy it is to have error on that, like when you're wiping this on to blue it and you end up bluing in a hill, a convex surface, right? But since we're now going to have both sides making contact, it's very hard for that error to occur just because there's a larger distance between those points, right? So that's really the whole point of this dumbbell. But this dumbbell was 62 millimeters on each side. What is that, 1.5 inches? 62, 25.4, 2.5 inches. And what we were using before to blue it in was a 1-2-3 block, which was 1 inch. So we actually have a larger base than we were using before. So we're probably going to see that we have a hole in the spots in the center, and we're now going to have to increase the width of the spot that we've actually scraped out. So but yeah, that's my little dumbbell trick. I think it works quite well. I think this is probably good to definitely below like 5 micron. Probably good to 3 to 5 micron, which I'm happy with that. That's a good starting point. Okay. So, now we're going to go back to the lathe. I'm going to keep the camera up a little higher so you get a little bit more top-down view. Okay. And that's the spot that we've been scraping. Let me try and find a good permutation of focus. How do I... Oops, didn't mean to hit record. Focus area, we're gonna focus on a small spot. And we're mainly working on, I guess right now I'm just gonna focus it over here. This is where the focus is set for the camera right now. Hopefully that is focusing in well. Okay, so now we get to take our ink and our brayer, and instead of using the 1, 2, 3 block to basically ink in things, we're going to now be using our dumbbell, which is going to go across. Bam. So we're probably going to do a couple scraping passes here until we even make good contact, because we've basically made, let me go grab my marker too. Man, I just brought everything to the surface plate. Grab the acetone, cloth. Okay, so kind of got all of our tools that we need. So far what we've scraped in is like this area here, right? So this area has been scraped in, and this area has been scraped in. Now these areas are just a little bit larger than, they're a little bit larger than the 1-inch block we were using. So these are about 30 millimeters wide is roughly what we just did there. So we've put in a hole here in these spots that is roughly 30 millimeters wide. But we're gonna come in here with this tool, which is a little bit wider. I'm gonna try and line it up with kind of the old lines here. And then I'm gonna make new lines. Okay. Let me acetone off these temporary lines. Okay. So now we have this bar that we can set across. And the theory is that now both sides kind of roughly have to have the same plane, and then this should go roughly in the center. Yeah, that's sitting pretty center. I don't want it twisting too much. I think right here is actually the correct center of this tool. It's a little bit back further, but whatever, it doesn't matter too much. Okay, so we're gonna go in and add the lines that we want to use. So let's line this up with the old spot, line this up with the old spot, and then we're just gonna go a couple millimeters past this, so we just have a little bit of room on each side. Same thing here. Scoop. Terrible with my right hand. Okay, and then these are going to be the lines that we're going to be scraping in right now. Okay. We can actually keep this bar slightly off screen here. Maybe I'll tilt you down just a little bit more here, chat. Perfect. How's the video quality? Okay, now we're gonna clean these up. Just clean up all the existing markings on here. We should also probably transfer this over to here, so we normalize the width here. I think that's the first thing we're gonna do, because this is the low spot on the lathe. I think we're actually gonna go and mark that out quick and I need to make sure I don't lose my markings here. I'll go a little up the V, which is really hard to hit. Okay. So we shouldn't lose our spot. This is where we're hitting. This inside spot is where we're going to be putting the level, which is right here. Well, I guess the level was indicated over here, and then I removed the point like a goober. But it was the center of those spots. We should be able to get the same value that we kind of were getting back when we originally put this down. And see what we get. $60 and then up 14. Okay. Yep, that seems to be pretty damn close to what we were getting before, so I don't think we've knocked anything out of bounds or done anything crazy there. And now we get to blue up our dumbbell and see what happens. So hopefully we have a hole on each side there. So this dumbbell also holds more ink, so that's kind of nice in terms of just how many times you have to go in and re-ink this. It's just a little bit easier to ink this and get a consistent ink layer on this than the small block. Here we go. Okay. Wow! Remember when I said that I felt like there was a hump over there? There's a hump over there. Bam! There you go. So that is why we used the dumbbell. You can see that there was, we have mainly, so you can see where the hole is, right? So the hole was at these lines, and sure enough, you can see that most of the contact is done outside of that hole. Over here, kind of the same thing, but you can see that here we're mainly making contact in the center, and here we're mainly making contact on this edge. And that likely means that we have kind of a slope down here, and this one's kind of like a ball. This one's like curved up here, a cylinder or a tube, right? So this is exactly what I was worried about and that I felt like I was feeling when I was bluing this up over here, and it's exactly what I'm seeing. There's definitely a curve. We're making mainly contact in the center there. Here we're mainly making contact on the edge. This side looks pretty okay. So now we have to go and fix this, right? We have to go and fix the state of these, and we're also going to reduce the amount of work we have to do, because before we were removing kind of everything, right? We had everything indicated here kind of on all over the place, and we were scraping everything, when in reality we really only need to be scraping a couple points. This is why bluing and scraping is very difficult, right? You have to really reason about kind of those properties. Let me change the go into the max f-stop here, just because things look like they're pretty bright. So A+, excellent quality. Yeah, I'm really happy with this video camera setup. Is this a normal amount of unflatness? This is probably better than most lathes that are in operation right now. So we're already kind of going a little extra. But yeah, isn't that wild? Because I definitely said I felt like it was kind of wobbling over there, and sure enough it was. So what we want to do is we want to get kind of this whole area that we're bluing in contact. We're going to end up going low here, and then we're going to transfer that low up to this original point. So this is the original low point on the lathe. Right now we're just going to worry about these two. So we're going to clean up these two spots. We're going to get these so they're bluing in correctly, so that will make sure that they're in the same plane. Then we'll use the level to flatten these out so they're both they're in the same plane, but they're also in a flat plane. And then we'll transfer whatever flatness we've created here up to here. This should be a minimal amount of scraping, because this is already our low point on the lathe. And then we'll have 3 points that hopefully should be all in the same plane, and that plane should be flat. So, alright, here we go. We're going to just make some passes here. I'm just going to hit everything that's blued, and yeah. So when I did all the scraping on this, I never used the dumbbell. I used the dumbbell for putting the level across, because my level has V's on it, so I was able to set the level on top of that bar, and that's how I originally got measurements across the bed of the lathe with my glass, water bubble spirit level, just kind of the standard way. Okay. Okay. I'm a little out of bounds here, but that's okay. All right. Same thing over here. Whoop. But yeah, the hardest thing about scraping is you can only remove material. If you end up removing the wrong material, you gotta go now do more work everywhere else. So I'm glad we built this dumbbell. Really didn't take that long to do. And now we can kind of get just a better surface that we're working towards right away. I know I kind of dismissed that earlier, but second thoughts on that one. So technically right now I don't even care about the level readings. I only care about the contact points, but just for curiosity's sake, we'll keep setting the level on here. Okay, so we're 12 high on that side, we're 62 high, and then 12 here. So, yeah, this is the main spot that's out. Okay, and we keep going. All right. But yeah, I think most lathes are probably built to probably 1/1000th of an inch, 1 or 2,000th of an inch per foot of flatness. So for a lathe like this that's like 4 feet long, it's probably reasonable that you have like maybe 20 to 30 micron of kind of sine wave waviness in the bed. I could be wrong on that. I know that this one was, I think this one was like down to a couple tenths, like 2 or 3 tenths, so like 5 to 7 micron, which I think that's what this lathe was built to. This is a very precision lathe, right? Like when this came out of the factory, this was one of the most accurate lathes on the market. I think at one point I read, and it's sometimes hard to know with the lore of these things, I've read that this is the lathe that the plutonium pits were turned on for the early atomic bombs, which I think I saw that on Wikipedia for the lathe. But yeah, in the 40s, this was hot shit. This was like, I mean, there wasn't CNC. Metrology gear was a lot harder to get, to make, to use. We didn't have, like, most things are made out of cast iron, so temperatures matter more. We didn't have as good of air conditioning and temperature regulation systems, so, like, it was harder to control temperature. And this was a lathe that you could buy, and basically truss to give you really good results for most of your precise work. So this is considered a tool room lathe, is what this is. They also made the 10 double E's in some other lathe formats. They made a non-tool room lathe. I think it didn't have a threading gearbox. So that was, I think that'd be a manufacturing lathe is what they'd call it. Or what they called theirs, at least, at Monarch. So this scraping is going really nice. You can see that it's probably not even worth it to do such a small contact patch like I was doing before, because most of the time is in bluing and measuring, and thus, like, the actual passes are probably only half of my time. So having a larger spot here doesn't dramatically increase the overall time per scrape measure scrape cycle, you know. So yeah, this lathe weighs, I think, 3,200 pounds, or like 3,000 pounds, but it's a very small lathe. So it kind of has the mass of a really heavy lathe, okay? And my battery is dying on this. It's still technically on, but it's about to pass out, so let me go and put some new batteries in this. And I'm probably going to have to re-zero it. I'm not sure what happens when the batteries die. So I'll go over and re-zero it as well. So, but yeah, this thing eats batteries. I don't know if that's because it's got an old microcontroller in it that uses too much power, or if just by nature, you know, whatever lasers they're using for the interferometer use a lot of power. But doesn't really matter. Okay. But luckily the batteries are easy to replace. There's just a nice cammed in little circle piece that you remove. Very easy to change them out. And I'll just re-zero it before I bring it back. So, come on. Okay, batteries are in. I just have to clean the dust off the surface plate because it's gotten dusty because I was kind of playing over here. And we'll re-zero this in. Should probably also clean the feet off of it. Okay, here we go. 2.9 volts on the battery. Okay, getting 0. Okay, reversed it. We're just waiting. Okay, and it is re-zeroed to absolute 0. And we're back. So, yeah, I wish the battery lasted longer. If it's a microcontroller, I feel like that's solvable. This thing could probably use 0 power, but whatever. Okay. 70 and +6. where we're at right now. Once again, we don't really care. We really only care about hitting the high spots, because we're going to have to fix the shape of the lathe. If these are not in the same plane, we're going to have to fix it eventually, so we might as well do it while we're doing our rough scraping. Especially when all we have to do is just use the dumbbell instead to indicate things in, so I'm happy with that. It's really not costing us much more time to do this. But in theory, we don't really expect the measurements to change much. Okay, trying to get a couple different things there. There we go. So we're already filling in a lot more here. We're starting to almost make contact in the hole that we made. This side is kind of filling out pretty good, so it's really just this corner is low. So we just got to slope down. And this one we still have that curve in there. But honestly, we're making really good progress. I feel like we haven't lost too much. Rare Gamozo stream. Yeah! Yeah! Geek Pirate was asking for one, so I thought I'd give one to him, even though he's probably not here right now. What a asshole. Demands the stream, doesn't show up. Okay. Nice. Those are pretty heavy. Oh, this side is so much softer. You can see how this, even just the scrapes kind of turn out better on this side, because it's just a softer, maybe it's not even softer, it's just consistent and there's not like hard and soft pockets everywhere. Because you can really feel the like stuttering when it's like biting in, then not, then gliding over different hardnesses and surface properties. Hell yeah! That was good. Okay, deburr it. Bam. Really, we don't expect to change the X value. We expect to change the Y value because we're lowering both. We're lowering this backside, this Y equals 0. This is staying stationary. So, and we are seeing that. We're seeing that this spot is getting higher. Kind of scary. I don't like that. We're gonna actually, since this side is high right now, we're going to work on this side only until we have a good contact patch. Because we already have a pretty good contact patch over here on this side. There's a chance that the reason that we're not seeing full contact is because of the warpage over here. So what we're going to do is focus on this side, because this is where we have the most material that we can remove without throwing off the rest of the lathe. So we're going to keep focusing on just that corner until we get rid of that saddle. I think saddle is probably the best term for that. Yeah, in the grand scheme of things, this contact patch over here is already quite good. Definitely flat. This one is not. So we're going to work on this, and we're going to hope that by the time that this gets low enough, that we make good contact, that we're about at 0, and we don't have to come back and remove material from these spots, because that literally adds work to the rest of the lathe. So it's really important that we just kind of get this right, and don't duplicate work, and don't increase the work we have going ahead. It's wild how visible the work that we're doing is compared to traditional scraping. Having that level in the loop really helps understand what kind of manipulations are happening on the surface here. Okay. Happy with that. And we really just have to keep going until it all blues in. So let's just keep fucking blasting. Really no need to go back in with the level, unfortunately, as much as I want to use the level. It's just not super valuable right now. We still have the hole there, so we still have like all this room that's fine to remove. So it's really once we start making good contact in that hole that I'll start to worry that we're not necessarily at the bottom where we want to be yet. But we know we have a decent amount of material to remove off here before we get level. So hopefully this isn't too big of an issue and we're not duplicating work. Otherwise, we might have started the stream kind of screwing this up by removing that, by going at this kind of blind without the dumbbell. Okay. Add a little bit more ink. Come on. Hey! It's getting better. We're starting to make edge contact there. So yeah, I think we're fine. I think we haven't really caused any damage. Woo! I think by the time we hit 0, this is going to be all nice and flat. Raise your poggers, chat. So these spots are barely making contact. I don't even know if I was supposed to scrape those yet. I'm going to try and stick to only scraping the shiny spots, which is normally not something I do, mainly because I want to be like, oh, I'm removing more, so I'm going faster. But sometimes that isn't actually making progress in the right direction. Why is one side softer? This is a flame-hardened bed. So one side probably had more wear. One side probably just had the flame on it longer. It's not a precision hardening process, right? I think literally they take like a fucking massive blowtorch to the entire bed until it probably gets hot enough, and then they probably dunk it in oil, depending on what heat treat process they're doing. Ultimately, it's just not a precision process. So look at this, man. This is cleaning right up. Hitting those high spots. That edge is coming in nice. Turns out that when you do the right thing, things go faster. Isn't that fucking crazy, chat? Okay. I'm only hitting the shiny spots. Only the shiny spots. But I'm eventually going to build a rigid dumbbell when I get to the end of this project. One that isn't built, you know, with V-blocks. And then I'll lap the contact bases in flat. And then that will be the final thing. But right now, this is good enough. Oh, get your Pog Champs ready, chat. Get your Pog Champs ready. Oh, look at that. Big Pogs. Big Poggos. Pog University. I don't have a great way to hit it from this angle. This is a hard angle for me to hit it from. Okay, we got a high spot there, mainly because it's out of bounds. That makes sense that it's high. That's good. Good. Yeah, and then high spots, of course, out of bounds, as we would expect. And effectively, as I'm scraping these, I'm kind of looking to the next points to make the decision of where I want to go next. And I'm really looking for those lighter blue spots where the ink has been rubbed very thin. So we're probably at 50 micron per meter on the level, would be my guess. Because I think we finally started to hit where we initially scraped that hole down to, which really wasn't that bad. That did not take that long. Let's take a look. Fucking told you. 46. Yep. So now we're starting to remove material. So we're kind of in a race. We're hoping that this area cleans up and gets good contact all around. That is what we want to see before we hit 0 on the level. And yeah, we're gonna get it. We're gonna fucking get it, chat. But yeah, I'm excited to make like a dumbbell. I'll probably make it out of cast iron. I'll probably just scrape it against the surface plate. So I'll make a really, really rigid cast iron dumbbell with precision scraped in feet. It's gonna be really fun. I just love making tools like that. Just kind of a unique, bespoke tool. Really only one major use. We're starting to have contact in these spots, which is very good. Loving this. This side of the bed starting to get some good contact. It's really just the side near me now that's missing the most contact. I did set this whole setup to do it from over on that side. So I'm kind of at a disadvantage in terms of the way my body's positioning isn't necessarily ideal. Just because the camera's kind of literally where I intended to stand. But, you know, for you guys it's worth it. Right? Okay. Okay. Starting to see a little bit heavier in here. We could go and get a level reading quick, just see where we're at. I imagine we're probably at 42. I'm happy with that. So we still have material to remove, and that's good. So far we aren't going backwards, which is really good. I don't want to go backwards. Wow. Could really feel the texture of the surface on those scrapes. Okay, we're gonna try a little heavier force here, like a little oomph on each one. See if that affects either the texture or the level reading. I'm not happy enough with this contact, maybe that spot. But I think these contact points are going to be ones that we're going to want to have, so I don't want to hit those yet. So we're leaving a little bit more there. It's just as those, basically as the contact points that you want to show up start coming in, you don't necessarily want to remove them right away, because then they'll never become contact points. Okay. Oh, yeah. Let's go. Getting a lot more evenly throughout there. We still kind of have that hole in the center that we initially made. So we're crushing it right now, chat. How is this process performed at the factory? Usually this is done by artisans. Most machines aren't done like this, but when you're looking at like $100,000, probably $500,000 plus CNC machines, mainly like your grinders, like CNC grinders, also other high precision machines like EDM machines are usually going to be scraped in by someone, and yeah, they're probably going to spend hundreds of hours on it. Literally just straight labor. Okay. Really only trying to hit the super high spots here. Here. This side of the lathe has never really cleaned up nicely, in my opinion. It's always kind of been pretty, it's always kind of had like 3 spots that are high. The edges, the center, yeah, the edges in the center basically are the only things that really ever get blued up here. So I'm really trying to kind of change up my tactics to hopefully get kind of a full pattern in here. But there's also a chance that there's just 2 channels that are worn that are deep in here, and we'll have to make a decision on whether or not they're too deep for us to want to even bother removing, or if we just want to leave them in there. But I think they're pretty close. I think it's just the scraping technique that I've been using where I'm not preserving the centers. Yeah, I think these centers should come in. But scraping is just very difficult. It looks like it's easy. And it probably is easy if you're given specific guidance for a specific problem. Like if you joined a company and they taught you how to scrape with their rigs and their setup that is known to work, it's probably pretty easy. But the hard part is just having something that works as a strategy. So that's high, that's high. Really not removing too much here. Struggling to see what actually is making contact here. A little bit out of bounds here. Don't really need to be here. It's probably high. Those are good. Okay. That felt really weird. I felt like I wasn't scraping a lot of it, but normally I'd scrape a lot more than that on the surface. But I'm hoping that maybe I'm getting better. Maybe I was doing it wrong before. Okay. Add some more blue to the dumbbell. So yeah, a lot of this right now is we're just trying to invent the techniques that we're going to use to get this lathe flat. Once we have techniques, we're just repeating the technique and doing labor. But right now, we still don't really know the best way to indicate everything in, clean everything up. Get a quick reading here. Nice. Okay, so we're still high 45. That makes sense. We still have a lot of material to remove. We're not removing a massive amount of material right now. We're really just focusing on trying to get these points to come in contact with the minimal material removal. Because if we go really heavy right now, we can't add the material back. It's important that I'm not doing finish scraping, so I don't have to have the tightest contact patch, or the best contact patches here. But I think a lot of the lathe, I think this is one of actually the worst spots on the lathe in terms of the contact. So if we can just resolve that now, it'll be less work in the future and a better reference surface for us. Okay. That's pretty good. Okay. That's not terrible. Definitely better than where we started. We're so close. When's the Minecraft gunsmith thing? I don't know. I haven't played Minecraft in a long time, so I don't know if I'm gonna do any gunsmithing in Minecraft. Is the goal to see a uniform blue patch across the whole section? Yes. Would it be easy for you to turn off autofocus? Yeah, I can do that. And then where is focus here? Let me do this. That's probably focus best. But yeah, I can, there you go. I gotta hit from this side now. But yeah, that's filling in okay. Really making contact on this high side now, from looking at it. Okay. And I feel like these just are not making great contact. I'll do just some light scrapes over here, not to really remove material, but just maybe slightly change, just cut down those peaks into 2 peaks. But I'm not really trying to cut there. Okay. Blue, 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 blue. I think I'm gonna start rubbing these a bit more to hopefully maybe thin out those spots a little more. Just so I can see the high spots a little better. Because I feel like right now I'm not getting great high spots. There we go. Now everything, yeah, I think everything here is a high spot. So, I'm seeing everything in there is light. There we go. Yeah, I think I just wasn't rubbing it enough. Okay. So now we're gonna hit everything here. So I'm really curious what kind of finish we're gonna get, because I've never... This part of the lathe has just always kind of looked like shit. So I'm hoping that for the first time we're gonna see really good points here. Okay, now we're cooking. And we'll throw the level on this pass. Let's come in with deburr it. Then we'll even acetone it this time. this area up too. Yeah, there's definitely a decent amount of built up cast iron in there. You can see the black. Which is all cast iron filings. Oh. Go and reestablish my lines here. Okay. Bam. So we're hoping that we still probably have like 35 to go. Oof. I'm seeing about 16 to go. I think we might just stop when we get to 0, because I think it will be good enough. And then we'll go in and really, like, we're not going to do finishing passes on the lathe in these micro spots. The finishing passes will be done with the entire bed in a straight edge. Okay. Some circles, some backward circles, some forward circles, some left to rights, some left to right, some circles, some more circles. It's kind of satisfying to watch, really? When an angle grinder produces better results, I actually have a really small die grinder that I have used on here. But we're at the level of precision where that's too coarse. But yes, you can do that. To be honest, for a bed that is this hard, I do think there is a chance that you could get a slightly better surface finish. Because these scrapes, you have to put so much force behind. You get some chatter. But I think scraping is a little bit more control. It's also just a quiet process. You can kind of zone out. Just go at it. But we're also doing a pretty large patch right now. I mean, this patch is probably 1/10 of the lathe. Maybe a little less, maybe like 1/12 of the lathe. But we're actually doing a decent amount of the lathe right now. So we realistically only have to repeat this process like 12 more times. And this is, from my knowledge, one of the worst spots. Not necessarily in terms of amount of material to remove, but in terms of the shape of it. Because it's kind of easy to take a already pretty flat surface and make it flat. It's much harder when you have warps and bumps and waves, in my opinion. Probably should have added more ink. This is going to be a very light inking. Most people will really only do really light inkings. I actually like to go pretty heavy on the ink, and then I hit the spots that are rubbed off. But sometimes people use very thin ink, and then they kind of hit everything. Kind of two different strategies there. Okay. Beautiful. Go deeper. Those are nice. Some of those are really satisfying scrapes. This side has a little bit more chatter and gumminess. I don't know if that shows up on camera, like how sticky it gets on this side of the bed. I don't know why. But it's just harder to get good scrapes. I'm happy with that. Some of the end there wasn't great, but the middle was really good. Okay. Now we're going to go heavy on the blue. So it's going to look like the contact patch is better, but it's actually just because we have a thicker, we have more showing up from the ink being thicker. But it also kind of, like, I usually will kind of let the ink run out off my tools, and then I kind of get a few different views. I get a view with heavier ink, which kind of shows what's coming up soon, like what areas are going to be showing up soon. And then as it gets lighter, you kind of get a better and better idea of what's actually making contact. Okay. See how there's way more there with the thicker ink? And honestly, a lot of these are real contact patches. Looks very hard, yeah. It's a hard surface and it's a hard process. It's both. But I feel like we're actually making progress. I mean, you see how quickly we're making progress here. I've never really made progress this fast when scraping stuff. So I do think we are going to stop here when we hit 0 on the level. So we'll probably do like one more pass here. But I think I'm not going to go for a perfect finish here. We'll worry about that at the very end. Although technically, there's a chance that by, if we do it now and make a nice pattern now and do like finishing passes now, we'll actually know how deep we have to go to get it to clean up. Because what if we have to take another 20 micron off here to get this to clean up because these holes that we're not hitting are so deep? Might be nice to know about those issues now rather than later. I don't know. That's a decision we have to make. Whether we want to try and get these 3 contact feet perfect and zeroed, or if we want to just focus on overall lathe geometry and not the actual surface finish first. I don't know if it really matters one way or another. Obviously, I will be doing final passes when it's complete, when everything is done and in the same plane. That's when I'll actually seriously focus on making these the nicest finishes I can get. But we could at least make sure we can get into those holes here before we make the decision of where the zeros are going to be on the lathe, because we're literally deciding the zeros. We're making the zeros for the lathe, and if we have to go beyond this point, then we have to bring everything else down with it, but it's really just an order of operations there. Put more ink on. We're going to stick with a high ink. Okay, I think we're getting what I want. I'm starting to see some of those holes fill in. I still see kind of two two little hole channels that run across it. It's really mainly the center and the edges making contact. But I think I am going to make the call that this finish is going to be adequate if we're at 0, and if we're not, then we'll keep going until we hit 0. But once we hit 0, we're going to be done with this area. Looks like we're at 14. So we maybe have like probably 2 to 4 more passes. But yeah, that's really nice. Did I come left or right last pass? I think I did left. Sometimes when I'm scraping, I'll make like DDR arrows, and every time I make a pass, I'll make a note of the direction I did the last time, because sometimes it's very hard to tell which direction you came from last, or if you take a break or get distracted or just off in your head. Also, this is a really small contact patch, but sometimes scraping is a like 45-minute pass. Okay. But man, this is coming in pretty good. So yeah, I'll very likely make a jig that's probably L-shaped that allows me to blue and get everything in the same plane. I might even make a parallel surface on top that can seat the level, and then I'll be using the level base as the same thing that I use to blue everything, which is kind of cool, having the same measuring instrument and you're combined with the indicating instrument. This is coming up pretty good. Really not that much more to go. And then we have to lower this third point up there. Once we get to that, let's make sure our feet are clean. Feet seem reasonably clean. It's in there. Okay, we're now low. We're low 10 micron. So we're done there. Now we need to, we're gonna hit this with one pass. And then we're gonna hit this with 2 passes. Because this is high. So we need to lower this spot. Let me mark where we're making contact there. Okay, so yeah, we've made that pretty damn good. If we go here, we should have kind of old style measurements. There is a chance that the lathe itself has gone out of level. I highly doubt it, but there is a chance that we haven't made as much progress as we think we have. It's just that the lathe itself has changed the level it's sitting in, but I think that's pretty unlikely. So yeah, I think we're gonna do, we need to come down here. Oh wait, that's saying it's down. Yeah, that's low. So we need to come down here, and we need to come down here twice as much. So we'll do 2 passes here for every 1 pass here. And that's gonna tell us everything we need to know. Okay. So we're gonna go in the center there. That's gonna tell us roughly the area that we're gonna be going here. Now we gotta reapply ink to both sides of this now. Okay, maybe want a little ham on the ink on one side there. And now we're not going to be benefiting from having something going across the bed in terms of keeping everything in the same plane, right? So the whole point of the dumbbell is to basically make sure that we're in the same plane there, and we're not going to get that when we're doing this. And that's why I need to have an L-shaped dumbbell at some point. But for now, we're going to just go with this, because I'm pretty confident that this side is flat. It's always read quite flat. So, there we go. Now we're starting to see. Actually, you probably hold these spots as better place. We'll do some of these, some of these, some of these. Wow, okay, so you can see how good our contact feet are on this area. It's a lot better. So, okay, so we're gonna do one pass here and two passes here, which is just kind of measurements coming out of my ass. We're only hitting the high spots. Okay. Man, this side is so much nicer to work with. Okay, and then these I'm just going to go really light, but I'm not trying to remove material. Kind of all the spots that are blued up, but not necessarily, spots that are blue but not necessarily shiny. I think I'm just gonna do, I'm just gonna touch them so that in case there is some like weird high spot there, it just gets some attention. So this area is actually not hardened at all, where I'm at now. So you can see how clean I'm able to make these scrapes. It's really just a lot easier than the hardened material, because this is all under the headstock, so this is not an actual sliding bearing surface. This is just basically where the feet are adjusted for the actual headstock itself. So honestly, I probably shouldn't even do two passes here, because these scrapes are going to be a lot deeper. It's just, man. After doing the lathe kind of all day, you start to forget how easy it is to scrape normal cast iron that isn't hardened. Way better. But it is possible. You can scrape. You can scrape the whole lathe bed, but it's hard getting a good finish on it. Okay. All right, let's see where we're at. Okay, so we actually still have to scrape here. This is really far up now. Oops. So used to going that way. Okay. So I'm gonna keep scraping this just a little bit. It's interesting, there's kind of a hole there. Oh, that's the original spot that we scraped there. But this is still a high spot, but I still want to get this to 0. Once this is at 0, then I'll worry about really focusing only on this one. So, that's the plan. Here we go. Now we're gonna do a right side. Did we do right last time? No, I don't think so. What I really need to do is set up an ASMR microphone for the scraping. I'll just make a 40 hours of scraping video where we do the whole lathe. Okay. Maybe I did go this way last pass. I forget. Okay. Damn. Woo. Could you use a diamond to scrape the hard and stuff better? I don't know. I'd be afraid it would chip really easy. Yeah, I don't know how hard this surface is. I am kind of curious. Let's clean the feet, try and get a good reading here. Okay. Ah! Did the whole lathe move? Let's hope there are schmutz on there. Okay, there are schmutz on there. Wow! PogChamp! This is low, 5 micron per meter, and this is high, 6, 7 micron per meter. Let that settle real good. So this still needs to come down a bit. Wow. Look at that. Look at that. Hey, it's almost like we know what we're doing now. Okay, we're gonna do a left pass. Still gonna do both because we're still low there. Bam. Okay. Okay. Man, it's hard to do these two spots. And I have to move my whole body to get to them. Okay. Nice. So happy with those passes. Those went really nice. Kind of in a rhythm there. Yeah. Okay, this is down 3. And this is high 3. So we still need to do probably one more pass. One more very light pass in that direction. Holy crap, chat. I think we're doing it. Trying to get a much better inking distribution on this roll, on the bar, since we're going for kind of more final, high quality passes here. Gonna try and stay within the lines here to give us the most accurate reading of just this area. If we start going out of the box, we start getting false readings, because you could potentially be going uphill and you could start marking low spots that aren't actually low or aren't making contact yet. That's looking good. Final pass here. We'll go from the right. But this is very likely the final passes of these 3 spots. Really focusing only on the high spots. Try not to hit false readings. We'll just break these up just very lightly. Really just making sure that when those do come in, they come in as 2 points rather than one blotch. Okay. 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 There's a chance that we're done with these spots. There's a chance that the readings come back different than we expect. It's got a long boot time. Hopefully I don't have to re-zero it. I don't think I have to. Come on. I think that's accurate. I'm gonna go re-zero it. This is saying that this is high. This is also high, so it looks like we came down a little bit too much in that one corner, but that's okay. Just gonna re-zero it. Make sure it doesn't get thrown off at all. Mode 0, go. But yeah, I think we're pretty much there. We expect that there's the high spot that we still have to fix. Okay, we're all good. Here we come. Here comes the data. Choo choo. Choo choo. Here comes data. Yep. So it's saying it's a little high on the right side here. Just barely, not enough for us to care. And then it's high up here, which is what we expected. We expected we have a little bit more work to do up here. I'm happy with this, chat. Oh, back down we go. My knees. Okay, now we're only working here. This is saying it's high over there. Okay. We'll do a quick left pass over here. Okay. Good. Okay. Here we go. Brrr, here comes data. Chug, 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 chug. A little bit more. Probably one more pass. Raise your poggers. Whew. All the data's made sense. Every time we remove stuff, it is coming out of where we remove it, which is a good sign that doing something right. Couple wiggles, little figure eight, some circles. Okay, hit this from the right. Okay. And is that it, chat? Is that the last one? Is that the last pass? I don't know. I feel like that was a pretty weak pass. Still high. Okay. This one. It's this pass, chat. This is the pass. It's this one, chat. I promise. Wiggle, 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 wiggle. Some circles. Some left circles. Some right circles. Some up and downs. Some back and forths. Okay. Is that left one? Left pass? I like left passes more. I think I'm way better at going from the left side. Okay. Okay. Whoops. Wipe, wipe, wipe. Deburr. Wipe it down. And it's time for the data monster. Open wide. Yum, 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 yum. It's the data monster. Son of a bitch. I'm happy with that. I'm happy with that, chat. Let's lock this bad boy in. Okay, so this is now the 0 for the lathe. So let me move off center, because this area should also be very close to 0, but probably not as 0-y. Wow, really? Is it just the one spot, or did I pick up a schmutz? Okay, back where we want to be. Yeah, it's 0. Go a little bit further. See, that's good. A little bit further. Okay. So, I mean, these are okay-ish, but it looks like really only the spot that we're measuring is hitting 0, and I'll have to map out what kind of twist or whatever's going on there. Oh, I think it's just up here, because this spot is high here. Okay, but we have set our 0. There should never be a negative y reading. Like here, this should be positive y. Yep. And on the other side, it should also be a positive y. Okay, it's negative a little bit. Yeah, hopefully those are now the 3 lowest points on the lathe. How does the hope? Such that everything can be scraped down to this point. Okay. So now, I need to put my dots back on, and I think we'll do a 1 measurement of the lathe. Is it ink or Bluey's Wii? After it hits 0, what's next? Yeah, I'm gonna map everything. But I'm gonna map everything. We gotta make sure that we actually hit this point when we go and do our sweep. I want to make sure this shows up, but we're gonna see, yeah, if we have some weird curve going on. I'm pretty happy with this where it is right now. So I just have to go and put my dots in because I lost my dots. In fact, we'll go in and wipe everything down here. But we have to make sure that we do not lose these feet center points. Okay. 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 Alright, now we can get the acetone out and clean off the bed, flats. Spooky. Spooky. Okay. Okay. Good. Bam. Now we'll run a 2000 grit stone down it, just to potentially take off any burrs or super hyperlocal high spots. Okay. And that is good. I'm seeing the high spots getting shined up by the stone. That means the stone's making good contact. Now we'll wipe it down by hand. And this is what we're going to image. Feels good. Nothing feels out of place. Kind of everywhere we got a little bit of shine. Okay. All right. Now let's bring the camera back. All right. Locked. Okay. All right. So I put markings every 20 millimeters here. Not a great way of holding this in here. This is really only kind of by eye. Isn't the most precise thing on the planet. Okay. I'm gonna put some of these further down here. more in the center. Okay. 76. What do you think it's going to look like, chat? Do you think we completely ruined it? Do you think it's fucked? Yeah, me too. Okay. Okay. We have dots. All right, chat. You ready for data? We got to do the data dance. Data dance. 1/15 of lathe. Pog. I think it's way more local of a spot than I hoped for. Here we go. Control C. Control break. Control. Okay. It's just not exiting. Man, I fucking love how easy it is to close applications on Windows. Works fucking great. Okay. Should connect in. We're connected. Data. Here we go. We're sweeping. Kill me -9. Yeah, you wish. It's Windows. Can't do that on Windows. There's probably some other process that opened the file within 3 fucking folders of it, so it can't close. What are the odds that we've improved the lathe, chat? What are the odds that we've made the 3 low points? 0? Yeah, I kind of agree. Okay. We're almost getting to our spot, chat. We're getting close to our spot. so scared, chat. And this should be our spot. At least very close to our spot. That looks good. 9 and 3. That's pretty damn good. But yeah, I think I'm gonna build that like L-shaped bluing rig before I really go much further. Because I think when I switched to the dumbbell, it was a big improvement, but the dumbbell is still pretty flawed for doing one axis when I'm going up or down the bed and not across. So we'll probably build that next before I make any progress here. Okay. Well, hockey game was on. And I gotta figure out dinner. Avs versus Sabres. Man, I haven't watched hockey in a long time. I used to like hockey a lot when I was a kid. As they're getting crushed, that's only 3 points. It's fine. It's fine. One to three. See, I told you. See? Sloop. Man. I'm really curious what we're going to get for results here. Unless we find out that there's something wrong with this approach, but if there is, that's okay. That means we learn. I think one of the biggest things is the X and Y, the X in this case, across the two waves is pretty out. I think there's like a twist effectively. And I've thought about maybe untwisting the lathe, but untwisting the lathe is just a little scary. I know. Especially since the lathe has had so much time to sit and settle and kind of find its equilibrium. I really don't want to like apply a twist to it because it's already found stability. My 3070 doesn't like your stream. It's probably because it's in 4K. Maybe you need a stronger GPU. 3070, what is that? 2 years old? That's like pre-AI skill issue. This spot's looking pretty zeroed. My GPU's at 5%. Can't watch a video in the background without dropping frames? The fuck? You using Firefox? Sounds like a Firefox user. Damn, we got a 0. A 0 reading here. It's a rare. Brave, Firefox is shit. It's kind of true. Sounds like a VRAM issue. Yeah, get your fucking... Get your AI porn neural net out of your GPU RAM. Make some fucking space. To be honest, who doesn't have a VRAM issue who has an NVIDIA GPU? Am I right, guys? NVIDIA doesn't give enough RAM, am I right? That's what I've heard on Reddit, is that NVIDIA doesn't give you enough RAM. Throw the GPU in the oven to reflow it. Data's coming in. Waiting for it to get all nice and stable. It's data time, data coming in. Data coming in. Got the data dance. It's wild how sensitive this level is. The fact that this lathe is just like all over the place is not insane. Has anyone ever reflowed their GPUs in the oven? I know that used to be a meta back in the day. It's fucking hilarious. But yeah, I think the biggest issue is I need to be marking this in with an L bracket. I think what happened is I'm probably putting a slope in there. Is my guess. Because the readings, I think there's a slope that passes through, and we basically set the center of those two slopes to the same point. That's my guess. Isn't it actually possible to just replace the VRAM chips with higher capacity ones? No. Well, you can, you can do that up to the max. Whatever the bus width is times the largest chip you can get. Yeah, firmware isn't gonna like it, but you could probably hack the firmware. Okay. Almost there. What's it gonna look like, chat? Is it gonna be bad or good? You have to flash a custom BIOS? Yeah, it is possible. But you wouldn't be able to go very high. Because the top-end GPUs usually already have the largest chips that you can get on the market. Maybe the low-end GPUs, you could end up upgrading those chips. But on high-end GPUs, they're pretty much always maxed out based on what the market supplies anyways. You're just so bus limited with the new HBM, like HBM3 or whatever it is. It's just hard memory. It's very fast, special. Okay. Last measurement, chat. Raise your paw, goose. Raise your paw, goose. There it is. Last data's in. Control C. Disconnected. Power down and put the level away. Look at that, chat. That was a successful Navy operation. We don't know yet. We won't know until we go put the data in the software. But we gotta clean up first. Okay. Let's put the level in. Scoop. Okay. Level is put away. All right. Now we go inside, chat. So let me take you in. Script. Okay. I'm going to take the cameras separate, I think. Hi! Hi, Bubble! Hi! Did you miss me? Did you miss me? Did you miss me? Did you miss me, Smush? Did you miss me? Okay. Okay, Smush. I gotta set this down. I gotta go bring in the stand. Okay? I'll be right back. I gotta change out of my outfit. It's okay. I know, it's so exciting. It's so exciting. Good boy. Good boy, Bumbo. Good boy. Mr. Smushies. Yeah, we're getting some water. You like water, Smush? Yeah? Yeah? Do you want a saltine? You haven't even found all the hidden saltines. Well, I'll give you one right now. Here you go. Good boy. Good boy. Enjoy your saltine, Smurfs. You little doofus. Alright, now we can go look at the data. The datums, the datums. It's nice and precarious. That's good. Like that. Oh boy. Oh, now we gotta change that f-stop. Yeah. Let's go like that. That's a good f-stop. Okay. All right. You want to go out first? Yeah, it's been a while. I know. Good boy. Thank you for asking me. I'm very proud of you for telling me right away. Good boy, go on out. Good boy, proud of you. What a smart dog. What a very good boy. Okay. Now we gotta pull down our data. Gotta go into the datums. Oh, I killed the HTTP server. Son of a bitch, I gotta go back out into the garage. Ah, fucking son of a biscuit. Okay, now we get to download the latest datums. Okay, now data lathe stream readings 2. Okay, update our software. Stream readings 2. Cargo run release. I'm scared, chat. Oh my fucking god, chat. That looks pretty pog. That looks very pog. See, I'm curious where that will settle in, but really this spot, these are the 3 spots we scrape. And we want this to be 0, we want this to be 0, and we want this to be 0. And we've got 2 zeros, and then this one's like 2 micron high. I'm pretty happy with that, man. As long as our measuring methodology works, I am really, really, really happy with this. Yeah, this area is high. This is really the area that needs the most work. It's interesting because it is saying that I could potentially rotate to a slightly better skew here. Let me turn off the skewage code. The X skew, Y skew stuff. Let me just comment that out. So now we won't be skewing ever. This is going to be using the absolute level readings rather than the relative ones. I think that breaks some of the minimization steps here. That's not necessarily, I think that's not good. We'll put the skew back in. Because, yeah, I'm curious how much the lathe bed maybe shifted when we've been operating on it. But I'm pretty happy that we have those zeroed points there. We might have not had it in a perfect plane. It looks like it wants us to, the skew looks like it wants to make us have a slight adjustment of it, but I mean, basically we see a 0, 0, and a 0 for those spots for, I mean, this is maybe up 2 micron, but really I need to have a slightly different platform that allows me to reverse the level. That's just really difficult to do since I have the overhang here. So I kind of need an L to sample this data, but I also want a way that I can rotate the level. Really what I should do is just do that and then rotate the level, and yeah, the data will only start like here, but at least I'll get some duplicated points here, kind of across the lathe. And that will allow me to kind of cancel out any errors I have in the actual zeroing of the level itself in terms of like the absolute values. But I'm really happy with this. I'm gonna let this cook and try and find a minimum. But yeah, I think our strategy is probably gonna work fine there, and then we'll just keep transferring these points further and further out. Maybe I'll flip the level, and I'll like have the L going this way, and I'll transfer a 0 to here. And then I'll flip the level again, and then transfer the 0 to here, and kind of repeat that process. That way I'm kind of flipping the level back and forth as I go. I don't know. But yeah, it's probably, how much time did we spend on that? It's probably 100 hours of work, would be my guess, to finish everything. But I also have to build that scraping tool. That's probably going to take probably 4 hours to machine, and then probably 4 hours to scrape that. But I'm probably going to make just some feet. I'm going to make some like 2x2 feet, and I'll make it so it can extend out to the very end of this lathe. What would be a good end result? I would say I want to get everything within 3 micron. Between the lowest and the highest point, I want it to be 3 micron. You want to come in, Pablo? No?
you want. But yeah, that's I mean, really, what we just did is we have a 0, a 0, and a 2.5. So I would say what we just did is probably plenty acceptable for what I actually want to accomplish. In reality, we'll see what's reasonable. We'll see how much things move around. But we're probably going to try and burn this hole like we did here. We'll try and make a hole over here. Or we'll make a hole here, then here, then here, then here. We're basically going to try... I think the goal is to have the level sit on 2 trusted points at all times, and then we're going to transfer to the other point. So effectively we want the level to read 0 across here, and then we'll have it stick out to here. We'll slam this down to 0, and then we can put the level with these 2 points being 0, and then this is only the high spot. We slam that to 0. Repeat the process until we have a bunch of zeroed holes throughout here. And then we can start rubbing a straight edge or like a larger tool and do more bulk, longer passes and kind of pull everything down to those pits. Then once those pits have all made contact, then we're probably within 5 to 10 micron, and then from there we start doing our finished scraping. So, yeah. But I don't know. I mean, I'm pretty happy with the size hole that we made there. I think that's a good size hole. We concretely have like a couple data points inside that hole there. So I'm really happy with that. It's really just this spot that's maybe high. Which is, yeah, I mean, if that's reading low and that's reading low, then that's high. So I could probably, now that I have this graphed out, I can go back out there, set it in that spot, and what I want is for it to basically read zeros in that spot, and that's going to be the absolute 0. But it'll be a long process, but I mean, that went pretty quick for what we just did there. And once we can use a straight edge across it, we'll be able to make a lot of progress really fast. Really what's slow right now is we're just trying to set these origins in. But yeah, there you go. That's the stream for today. I'm gonna order some food, or maybe go out for food. I don't know what I'm gonna have to do here, but I'm hungry. Alright, see you later.